In some regions of the Pacific Ocean, ships sink very easily, which is why it is feared by many sailors. Although there are many routes in that area, there are some that few dare to risk because crossing them can mean facing extremely dangerous forces of nature. If you need to travel from Asia to America by ship, the most obvious route would be the shortest and quickest. That is, a nearly straight line under the North Pacific Ocean. But instead, it might be better to avoid crossing this place and opt for longer and more expensive but much safer routes. There is not one, but several reasons. The Pacific is home to some of the most dangerous waters in the world. When we open a world map, we usually see that the Pacific Ocean is kinda divided, which prevents us from realizing how big it is. But in reality, this giant covers almost a third of Earth's surface. It's about 10 times larger than the smallest ocean in the world, the Arctic Ocean. In other words, when crossing it, the chances of being cut off from any landmass are very high. And in cases of emergencies, mechanical failures, or even storms, help might take days or even weeks to arrive. This significantly increases the risk of serious accidents, the possibility of cargo loss, and, in more serious cases, something even worse. Now think about it. A ship journey from Santos, Brazil to Cape Town, South Africa covers a little more than 3,400 miles. To get from Callao, Peru to Shanghai, China, you need to travel around 10,000 miles. Another major problem that prevents sailors from crossing the Pacific is storm systems, whose name already indicates what they contain: unpredictable and therefore dangerous storms. In addition, near the equator, there is a chain of winds called trade winds that directly influence the climate in the tropical region and occasionally cause rain. Trade winds are strong and constant winds that act like a whirlwind that rotates without stopping. And although they are extremely important for nature, as they spread moisture through forests and even influence the formation of deserts, they pose a problem. Their intensity changes depending on the season. In winter, for example, they can be much stronger. And since these winds are responsible for moving the ocean waters, they also create strong sea currents that could make the journey much more dangerous. In 2015, researchers came across a series of extremely strong winter trade winds that caused a surge of short but intense waves in the Pacific Ocean. They observed that those waves began to hit the ship with constant force, as if they were repeatedly punching it. As a result, the hull structure was completely twisted and deformed. And in the end, they confirmed what they had already known. Those waves, caused by winter trade winds, could be a real threat to vessels. And by the way, do you remember that help in the middle of the Pacific can take a considerable amount of time to arrive? So, now there is much more than one reason behind the hostility of the winds. Such a large ocean doesn't have many geographical barriers, such as mountains or large islands. It means that there are no land structures around it that could hold back or slow down the winds and currents. So the trade winds and ocean currents have complete freedom to gain strength and speed. This explains why the Pacific is the scene of powerful storms and giant waves. This is different, for example, from the North Atlantic, where North America, Europe, and Africa help to contain and redirect the atmospheric and maritime systems. It is now very common for scientists to see the bottom of the Pacific Ocean as a giant jigsaw puzzle because it's literally full of moving pieces. It's home to the largest number of tectonic plates on the planet, and one of them, the Pacific Plate, is the largest maritime plate that science has ever identified. This particularity makes the region extremely unstable to earthquakes and volcanic eruptions. Even though the ocean may seem calm at first glance due to its geology, things can change very quickly. This makes it unpredictable and treacherous. For example, in 2022, the cargo ship One Apis was crossing the ocean, 1,600 miles northwest of Hawaii, when it was caught in a torrential storm. As a result, more than 1,800 containers were damaged, falling to the bottom of the sea. Hundreds more collapsed on the deck, turning into a real-life steel domino due to the force of the wind. The captain managed to steer the ship to Japan. The journey lasted about a week, and it was only when they got there that they understood the extent of the loss. But it wasn't just the one Apis. The following year, the ship Maersk Essen lost about 750 containers, while the Maersk Eindhoven lost more than 260. In both cases, the routes were bound for Asia. These three alone have already accounted for much more than the global annual average of containers lost at sea, which is about 1,382 per year. And the most curious thing is that these events happened in winter. Speaking of winter, it was in the winter of 2020 that the Pacific made history. Scientists recorded a 58-foot-high wave in the ocean, which is equivalent to the height of a 5 or even 6-story building. In general, a wave is considered giant or extreme when it's more than twice the height of the others around it. This one, however, was almost 3 times bigger than the rest. Now, it's important to remember that despite being rare and scary, these waves are not a tsunami, as they're caused by wind. Tsunamis, on the other hand, usually occur after underwater earthquakes or volcanic eruptions. Another big monster of the Pacific are typhoons, and the 2024 typhoon season confirmed this. One of the highlights was Hurricane Christy. It did not touch the crust, meaning it did not cause direct damage, but we cannot underestimate it. Christy reached Category 5 on the Saffir-Simpson scale, which is the maximum level. A hurricane of this degree is considered catastrophic, so it's no wonder that it was powerful enough to generate huge waves and extremely dangerous rip currents. In addition to this, there was also Super Typhoon Yagi, which hit the Asian continent with such force that it gained the reputation of the most powerful in the last 70 years. When it arrived in Vietnam, it caused around $1.6 billion in damage, destroyed infrastructure in several cities, and left a trail of victims wherever it went. As if that weren't enough, the Pacific is also home to one of the most unstable regions on the planet, the famous Pacific Ring of Fire. It's a huge, crack-shaped area that's home to intense volcanic and seismic activity. It's the most tectonically active place in the world, as the plates of the Earth's crust are constantly moving there. They move apart and collide, or grind against each other, which causes the region to experience earthquakes and volcanic eruptions all the time. Seismographs record some type of tremor there every 5 minutes. This dangerous region is responsible for about 90% of the planet's earthquakes. So, 9 out of 10 tremors occur within this ring, which stretches across the northern Pacific. And the worst part is that it doesn't just affect North America or Asia. In 2023, tremors linked to the Ring of Fire were felt in several Latin American countries, such as Argentina, Chile, Ecuador, and Peru. There was a trail of destruction, and the lives of around 15 people were lost. There's no shortage of reasons for ships to avoid the shortest route across the Pacific and opt for longer routes. As the popular saying goes, prevention is better than cure.
If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now, normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes, like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only 2 confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, It's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these two being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems, far from river discharges like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, Imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it's spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
Get ready, because one of the Pacific Ocean's most active volcanoes might blow any minute now. Scientists monitoring axial seamount, a gigantic underwater lava factory just off the coast of Oregon, say it could erupt literally any time between today and early 2026 at the latest. Yes, it's underwater, but don't get tricked by the ocean's cover. This beast is almost 3 times taller than the Empire State Building. This volcano is inflating like a souffle at a Michelin-starred restaurant, and scientists are so excited they will live stream it. Seriously! So here's the thing. This volcano will explode at any moment now because, well, it's inflating fast. Over the past few months, researchers have noticed that the seafloor is literally rising. It's like axial is doing its best impression of a waterbed filled with molten rock. Scientists call this inflation, which sounds like something you'd complain about after Thanksgiving dinner. But in volcano terms, it means magma is piling up underground, causing the seafloor to bulge like a souffle that's this close to collapsing. Now, an underwater volcanic eruption might not sound so exotic. After all, most volcanic activity on Earth happens under the sea. Believe it or not, there are more than 1 million submarine volcanoes quietly churning lava beneath the waves as you watch this. The ocean floor is Earth's biggest volcanic hotspot. What makes axial seamount so thrilling is that it's under intense scientific surveillance, unlike any other underwater volcano. It's like the star player in a volcanic reality show, with a network of ocean bottom instruments giving researchers real-time updates on magma movements, seismic tremors, and crust deformation. In fact, axial seamount hosts the world's first-ever underwater volcanic laboratory. Scientists have been keeping a constant eye on it since the 1990s, when they installed sensors that now relay live data straight from the seafloor. This kind of monitoring is unheard of elsewhere and has turned axial into a geological celebrity, one whose behavior we can track with remarkable precision. Besides, axial is hilariously predictable. It erupts roughly every decade, and right on cue, it's gearing up for another performance. By mid-2024, it had inflated to nearly the same level as before its last eruption, which means the countdown is on. Scientists are so confident in its schedule that they've set up a volcanic advent calendar, waiting for the day when axial decides to pop. But hold on, axial seamount isn't just your average underwater volcano. It's got style, personality, and a geological identity of its own. Now, most underwater volcanoes, called seamounts, tend to look like cones or flattened domes. Axial laughs in the face of tradition with its unfashionably rectangular caldera, a 2-by-5-mile crater that looks like it was designed by a geologist with a ruler and a grudge against curves. Most volcanoes opt for the classic circular look, but axial, it went full avant-garde. This caldera is punctuated by fissures, vents, lava channels, and mysterious dome-like structures that rise hundreds of feet high. It's like the volcano's wearing a funky geometrical crown instead of the usual rounded hat. What's more, axial's location is like prime real estate for geological fireworks. It sits right where two major forces collide, literally. First, it's on the Juan de Fuca Ridge, an underwater mountain range formed where two tectonic plates are slowly pulling apart, like a zipper being undone. Second, it's perched atop the Cobb Hotspot, a deep mantle plume that acts like Earth's sneaky magma espresso machine, pumping molten rock from deep inside the planet and fueling a whole chain of seamounts. To put it plainly, it's like the tectonic plates are reluctant dance partners, sliding away from each other, while the Cobb Hotspot acts as the DJ, turning up the heat and keeping the magma party going. This dual influence creates a complex plumbing system inside the volcano, with magma chambers filling, draining, and shifting in ways scientists are still trying to decode. The competition between the spreading plates and upwelling magma is what gives axial its unique geological fingerprint, and it's also why this volcano keeps surprising us. Now, we said that Axial Summit isn't just a crater. The truth is that inside, the action gets even weirder and cooler. Well, hotter, but you get it. Axial hosts black smoker hydrothermal vents, which blast superheated water at temperatures exceeding 700 degrees Fahrenheit. This is no ordinary underwater hot tub. These vents create one of Earth's most extreme environments, where bizarre creatures thrive in total darkness and scalding heat. Giant tube worms, crabs, colonies of bacteria, and even octopuses live off the mineral-rich plumes that gush from these vents, forming ecosystems completely independent from sunlight and photosynthesis. It's like an alien world beneath the waves, thriving off the volcano's fiery breath. These vent communities are crucial to science, not just because they're strange, but because they may resemble the earliest ecosystems on Earth. Some researchers believe life on our planet may have originated in similar deep-sea hydrothermal environments billions of years ago. Studying them could also help us search for life on icy moons, like Europa and Enceladus, where similar vents might exist beneath their frozen surfaces. When axial erupts, it's like a natural reset button for these communities. The lava wipes everything out, but within months, life comes roaring back. Proof that even in the most hostile environments, real estate is always in demand. For those worrying about tsunamis or coastal disasters, relax. Axial's eruptions are the underwater equivalent of a slow cooker. The immense water pressure keeps things chill, well, scalding, but not explosive. So the worst thing that happens is some lava decorates the seafloor, and a few crabs have to find new vents to squat in. This means no massive ash clouds or explosive blasts that could reach the surface. Instead, lava oozes out and spreads across the seafloor, sometimes traveling for miles. But for scientists, this eruption is the golden ticket. Understanding axial's patterns could help predict eruptions elsewhere, even on land. Plus, its bizarre ecosystems offer clues about how life might survive on other planets. Not bad for a volcano that mostly just sits around looking rectangular. Still, the volcano's activity can be heard in the form of thousands of small earthquakes every day. Thousands! As if the volcano itself was groaning and creaking, preparing to burst open. Again, we won't feel a thing, but at least they'll help scientists track the magma's movements and the volcano's eruptive cycle. Now, one of the coolest parts of this story is that scientists are preparing to live stream Axial's next eruption for the first time ever. Imagine watching an undersea volcano in action, live, as it's painting the ocean floor with fresh lava. It's like a front row seat to a natural fireworks display, thousands of feet beneath the waves. The livestream will come courtesy of the Ocean Observatory's initiative, which maintains a series of fiber optic cables linking Axial's instruments directly to shore. It's the Wi-Fi of the deep sea, and it's about to broadcast molten rock in HD. And there's another twist. Scientists have noticed a curious pattern in Axial's eruptions. All three of its most recent eruptions, in 1998, 2011, and 2015, happened between January and April, the months when Earth starts moving away from the Sun. So why? Well, it might have something to do with the Moon's gravitational pull. The Moon's orbit causes ocean tides to rise and fall, which changes the pressure on the seafloor and could help nudge the magma chamber to its breaking point. I guess the Moon isn't just a romantic light in the night sky. It might be the ultimate volcanic whisperer. So, one thing's for sure, when Axial goes, it'll be the best documented underwater eruption in history. So, keep your eyes peeled. This is one natural spectacle you won't want to miss. And who knows, if we're lucky, we might even get deep-sea eruption ASMR out of the deal. Now, if you'll excuse me, I'll be refreshing the live feed like it's a Taylor Swift ticket sale. Now, history teaches us that the supercontinent existed a long time ago, around 300 to 273 million years back. At that time, all the continents on Earth were buddies and hanging out together. They formed an amazing crew called Pangea, or Pangea if you're feeling fancy. The name comes from a Greek word which means all the Earth. Pangea also had a massive water neighbor called Panthalassa. So our entire world was a huge piece of land surrounded by a huge piece of ocean. The megacontinent looked like a giant sea, stretching between the tippy top and bottom of our planet. But as stories go, things changed. About 200 million years ago, in the early Jurassic epoch, like dinosaur times, Pangea decided to throw a breakaway party. Forget about the old ideas of continents just drifting around like big icebergs. It split up into smaller chunks, forming the continents we know today. Oh, and it created the Atlantic and Indian Oceans as a bonus. Pangea's tale was first told by a German weather expert named Alfred Wegener in 1912. But how did he learn about something that happened so long ago? Imagine the Earth's core as a big, cozy fireplace, giving off heat. This heat creates special swirling currents in the Earth's outer shell. We can think of it as the Earth's crust, which looks like a big puzzle with many puzzle pieces. The hot currents make these puzzle pieces, called crustal plates, move around. Sometimes they push apart, sometimes they crash into each other, and sometimes they slide past one another. It's like a fantastic dance party that goes on beneath our feet. One day, Wegener looked at the shapes of the continents and thought that, hey, those coastlines of South America and Africa kind of fit together. And they really did. So he imagined that way back, all of the continents hung out together as one big landmass. But he couldn't just go and say that without any proof. So how do we know Pangea really was a thing? Well, there are some clues that brought us to this amazing discovery. One clue is like when you put a puzzle together and the pieces fit just right. Take a look at the shapes of today's continents. You'll notice that they could fit together almost like a perfect match. Obviously, their shapes changed over time. It happened millions of years ago, and since then, the shores of continents have been washed by waters for years. But even so, we can still see how well they fit together. Another clue comes from checking out fossils. We know that ancient animals left a lot of fossils behind. That's how we learn their history and what species there were. But when scientists compared fossils found on different continents, they found something interesting. These fossils look similar. Surprisingly, they belong to the same groups of animals, even though they were far apart. It's not like these animals could swim across the ocean on their four paws. And it's unlikely that this particular type of animal originated in two places at the same time. And finally, the mountains. Imagine exploring underwater and finding huge mountains in the oceans. These underwater ranges and deep trenches are like scars from when Earth's tectonic plates moved around. They serve as another proof that the continents are part of something bigger. When you look at these things together, you get a pretty clear picture. The Earth's continents were once huddled together in the supercontinent. They've since gone their separate ways, but the memories of their grand adventure are still written in the shapes of coastlines, the rocks they left behind, and many more. But it's obvious to us now. At the time of Wegener's discovery, there were different ideas flying around. Some folks thought that the continents sank down to make the oceans, but Wegener had a different take. He thought that the continents are always on the move. He even came up with a fancy phrase, continental drift, to explain it. Later, he was joined by another scientist named Alexander du Toit. He added a little twist to the story, suggesting there were two original continents, Laurasia in the north and Gondwana in the south. But the real party didn't start until the 1960s, when scientists figure out the secret ingredient in this recipe, plate tectonics. And finally, this theory explained everything Wegener and du Toit talked about. Wegener's theory was proven correct after 50 years. As time passed, we learned more and more about our planet. We found out that the Earth used to have multiple supercontinents. Before Pangea, there was a megacontinent called Rodinia around 1 billion years ago. And later on, Pannotia joined the scene about 600 million years ago. What's interesting is that the continental drift story is far from over. Our continents are always on the move. Africa is giving Europe a friendly bump, and Australia is playing a game of bumper cars with Southeast Asia. You know what's on the horizon? Another supercontinent. So, how will this next supercontinent come together? Well, there are 4 major possibilities: Novo Pangea, Pangea Ultima, Orica, and Amasia. These might sound like superhero names, but they're actually ways the puzzle pieces could fit. Let's look at them all. First, Novo Pangea. You know how there's the Atlantic Ocean on one side and the Pacific Ocean on the other? Well, if these oceans keep doing what they're doing now, the Atlantic will keep opening up while the Pacific squeezes in. If that happens, the Americas, North and South America, will give each other a big high five. And Antarctica, that icy land way down south, will join the fun too. It'll be drifting northward. Next, Pangea Ultima. In the future, the Atlantic Ocean might get tired of being so wide. It might decide to slow down and shrink a bit. The Americas and the northward drifting Antarctica will probably crash into Africa and Europe. And just like that, a brand new supercontinent forms. There are these spots where the ocean floor is sliding underneath the land. It's like a secret underwater passage. These spots are called subduction zones. So if these secret tunnels will be spreading and spreading all along the east coast of the Americas. The Americas, Europe, and Africa might come together again, and they'd form a supercontinent. This supercontinent would be surrounded by the Pacific Ocean. The next possible supercontinent is Orica. In this scenario, the Pacific and Atlantic Oceans might decide to take a nap and close up. But don't worry, because when one door closes, another opens. In this case, a whole new ocean would pop up to replace them. Imagine a big crack in the ground cutting through Asia, like a zipper opening up. This crack is called the Pan-Asian Rift, and it would become a brand new ocean. With this new ocean comes a new supercontinent, Orica. Australia is currently drifting northwards, like it's trying to find a nice spot at the center of our planet. East Asia and the Americas might join in from both sides. After that, Europe and Africa might link up with the Americas, and boom, Orica. And finally, Amasia. It might form if some of the tectonic plates go north. They can take continents like Africa and Australia along for the ride. They'll be hanging out around the North Pole. All the continents except Antarctica might come together. And even though they might gather around the North Pole, they won't close off the oceans. The Atlantic and Pacific Oceans would still be open for business. How this grand reunion happens depends on the Earth's tectonic movements. So far, we believe that Novo Pangea is the most likely scenario. It also depends on what exactly happened to Pangea after it broke apart. And when the new supercontinent appears, what's going to happen with the weather? How will the ocean behave? And what about the animals and plants? These questions all light up our minds. Who knows? Maybe someday our descendants will look at the world map and see this incredible journey come full circle. So keep asking curious questions and stay tuned for the next 100 million years.
Your kitchen sink is filled with dirty water. You've just washed the dishes and you pull the plug out of the drain hole. Do you see how the water forms a funnel and all the pieces of food get into its center? This is a small whirlpool. Now imagine that this is not a kitchen sink, but a sea with a several feet wide whirlpool. And it draws in not pieces of food, but a small boat. And you're on this boat. You jump off the side and try to swim away. But the whirlpool is stronger than you. It attracts you despite your attempts to swim away. So the first thing you should do is calm down. Yeah, it isn't easy when the deep sea is trying to swallow you up. But if you don't save your strength, you won't be able to survive. And now remember one life hack. Do not try to swim in the opposite direction when the current from the shore carries you away. Head to the side. Thus, you escape from the stream sooner or later and can safely swim to the beach. Inside the whirlpool, you have to act similarly. You need to stop struggle and swim in the direction of the flow. Thus, you'll keep your energy and increase your speed. But don't swim at the very center of the vortex. Try to move away from it in the last moment and you'll get out. Now go to the surface and stay away from the whirlpool. Great! You have survived. You promise yourself never to go to sea again without a life jacket. But of course, the best way to escape from the whirlpool is not to get caught. If you're going on a sea cruise or kayaking at the mouth of the river, find out all about these places. Perhaps they are filled with water traps. You swim to the shore and decide to learn all about whirlpools. It forms in the sink or bathtub because the water begins to drain into the hole and swirl. There are no drain holes in the sea, lake, river, or ocean, and water is formed there because of the collision of two currents. A strong wind can only create one current. The difference in water temperature and its density can make another. Also, the current can be caused by tides. This is when the moon's gravity affects the water. So when two currents flowing in different directions meet, they form a vortex. Two streams of water swirl around each other and move down in a spiral, creating an empty space in the center. Most of the whirlpools are too small and don't pose a danger. But if the water vortex is strong and large, it can sink ships. Such strong whirlpools are called maelstroms. They are usually formed when two currents collide near narrow reservoirs and straits. The world's largest and most dangerous maelstrom is located in the Saltstraumen Strait in northern Norway. Every 6 hours, a whirlpool forms there with a diameter of about 33 feet wide and 16 feet deep. And it can be several whirlpools formed at once. Ships sailing through the bay follow a strict schedule to avoid falling into the water trap. This whirlpool got into the Guinness Book of Records as the largest in the world. However, some whirlpools are hundreds of times bigger, but they are invisible. Giant whirlpools in the Arctic Ocean can reach 18 miles in length. This is the size of a city, and these giant whirlpools are invisible. Fortunately, they are not as dangerous as those that form in Norway. The waters of the Arctic and Atlantic Oceans mix and form water vortexes invisible to satellites. Usually scientists notice such whirlpools with the help of thermal imagers or a change in the color of the water. When the current filled with marine life mixes with lifeless waters, it is visible from the satellite. But the new giant whirlpools are masked under a layer of water with the same temperature. They hide deep enough not to be noticed by satellite thermal imagers. Scientists manage to catch them using gliders. These small pilotless submarines float underwater and record information about the temperature and salt level. Scientists discovered that these whirlpools formed because of the collision of cold and warm currents. Warm water here is rich in nutrients, while cold water is almost lifeless. In this way, warm currents share useful elements and spread them evenly throughout this region of the ocean. Observing invisible whirlpools can help scientists uncover many details about the structure of ocean ecosystems. Whirlpools exist not only in water but also in space. Vortexes from the plasma energy of the sun can be several times wider than the radius of our planet. However, all this solar radiation cannot create giant vortexes on Earth because the magnetic field protects us. The solar wind glides past the planet's atmosphere like a wind over the ocean's surface. But a little energy still manages to break through the protection. Solar whirlpools insert an electrified gas into the magnetic field, creating holes through which the sun's plasma passes through the atmosphere. If whirlpools happen during the collision of different currents, it means that you can predict their appearance in advance. But there are unpredictable natural phenomena in the seas and oceans that pose a danger for small boats, yachts, giant ships, and oil rigs. The phenomenon is called a rogue wave. So now let's get aboard your yacht and sail somewhere in the ocean. It doesn't matter what ocean and where exactly you are, because rogue waves can appear anywhere. A small storm is starting, but your boat can easily handle it. The wind raises small waves that beat against the hull of your yacht. But then, among these waves, one giant appears several times larger than all the others. It would quickly turn your vessel over like a paper ship. But fortunately, this wave passes by and dissolves into the sea. This unpredictable wave of enormous power can destroy huge ships in a second. And such disasters have happened many times. Sailors all over the world told each other stories about the giant waves that appear during a storm and in a quiet sea. Many considered such waves only fairy tales, such as legends about the Kraken and Atlantis. But at the end of the 20th century, people were able to capture this sea phenomenon with a laser detector that measured the size of the wave. On January 1st, 1995, a massive rogue wave crashed into an oil station in the Norwegian North Sea. There was a storm that day, with big waves about 40 feet long. At some point, they formed a big guy, an 85-foot wave. That day, rogue waves turned from a fairy tale into reality. Researchers estimated that this natural phenomenon may destroyed about 22 supercarriers only in the second half of the 20th century. Also, scientists discovered that just 1 in 10,000 waves is a rogue one, and every year, their height increases by 1%. Some of the largest rogue waves reached a height of 100 feet. It's like a 10-story building. This giant can easily break even the strongest and largest ship. Scientists can't always predict their appearance, and still don't know their nature. So rogue waves make the ocean a much more dangerous place than we thought. According to one version, rogue waves appear because strong winds create big waves. When two such of waves collide with each other, a giant rogue wave may appear. Another theory says that eddies create rogue waves. These eddies form along the edges of the ocean currents, and then they drift separately for a long time, increasing kinetic energy and forming eddies field. The kinetic energy contained in these fields can charge the waves and increase their strength. However, scientists study microwaves and light to understand this phenomenon better. It turned out that these sea waves are similar in their behavior to these two natural things. The researchers hope studying light waves will help understand the nature of rogue waves.
Hey, don't freak out. Those red waters you see aren't blood oceans. It's just a natural occurrence called the red tide. Red tides often happen in Florida, especially in the West Florida shelf, and they can stick around for weeks or even months. They're basically caused by an increase in algae levels, hence the color. Those algae produce toxins that can be harmful to marine life. They can also be bad news for us humans, causing symptoms like upset stomach and urgent bathroom trips, if you're picking up what I'm putting down. Volcanoes are super scary, but there's nothing scarier than getting taken out by a pyroclastic flow. These fiery flows move crazy fast and reach insane temperatures, like hotter than your oven on a pizza night. They're like a fireworks show of volcanic eruptions filled with ash, lava, and hot gas, speeding down mountains at 50 miles per hour. Some researchers claim they might even hit speeds of 450 miles per hour, almost as fast as a passenger jet. If you're unlucky enough to be in the path of a flow, you're in big trouble. The heat alone can turn you into a human barbecue, even if you try to hide in a building. The air around the flow can reach temperatures high enough to fry your insides, burn your clothes off, and leave metal melted into your skin, which almost sounds like a Marvel origin story. However, a lot of people have met their end because of these flows. But there's one crazy story about a guy named Luger Silbaris, still sounding like an origin story. So on the 7th of May 1902, there was a major eruption on the island of Martinique. The night before, Silbaris had gotten into trouble and ended up in jail. Maybe this is a villain origin story. He'd been locked in a sturdy cell facing away from the volcano. The next morning, Mount Pella unexpectedly erupted, destroying St. Pierre within minutes. The flows wiped out around 30,000 people, but Silbaris survived in his cell and became known as the guy who lived through doomsday. The rescue team found him 4 days later. By the way, the cell still stands today. I hope somebody tested him for superpowers. Back on August 21st, 1986, a guy stumbled upon some animals showing no signs of life on his way to Nios village in Cameroon. To his shock, he later found out that everyone in the village had mysteriously passed away. The same thing happened at Lake Manaun in 1984. Turns out, those tragic incidents were caused by something called limnic eruptions, which are pretty rare disasters where carbon dioxide suddenly bursts out of lake waters, creating a hazardous gas cloud. These type of eruptions usually happen in lakes with high levels of CO2, which can be caused by things like volcanic gases and high pressure. Any little change in temperature or pressure can set off an eruption. So, experts have started looking into ways to safely release CO2 from lakes like Manaun and Nios in order to lower the risk of more disasters in the future. In March 2024, a video captured a terrifying moment of a woman disappearing into a sinkhole while browsing through a Chinese department store. Guess she got more than she bargained for. Ha ha ha. Moving on. The scene unfolded as the floor beneath her gave way, sending her plummeting into the abyss. In the midst of the chaos, another customer frantically ran away before returning to check on the woman who had fallen. Their quick thinking and the swift response of emergency crews and firefighters saved the day, resulting in only minor injuries for both women. I'm glad that lady checked on her because I would be gone. An anvil cloud is basically a big cloud made of ice particles that forms at the top of really tall thunderstorms, or those huge cumulonimbus clouds. The flat top shape is caused by the air rising in the storm and spreading out when it hits the stratosphere. That's why it's called an anvil. It looks like the tool metal workers use. Duh. The air from the anvil cloud is cooler than the stratosphere air, which keeps it from going any higher. You can spot anvil clouds from really far away, sometimes over 100 miles. Often you might see streaks of snow coming from the edge of the cloud known as virga. The snow disappears before hitting the ground because of the dry air. If you notice clouds poking through the flat top or bubbling up, it's an overshooting top, a sign of a super strong storm. Anvils are known for producing dangerous lightning. Normally, lightning comes from the bottom of a storm, but anvil clouds can produce really powerful lightning from the top. This lightning can strike out of nowhere, even from up to 30 miles away. so keep an eye on those anvil clouds if you see one forming nearby. Lahars are no joke. They're basically fast-moving, super dangerous streams of rock, ash, and water that come down the slopes of volcanoes. It's important for everyone to be aware of them. Scientists, policymakers, and even us regular folks. By understanding how lahars work and their potential impact, we can try to stay safe when volcanoes start acting up. Saving lives during natural disasters is the name of the game. There are two main types of lahars: debris lahars and mudflow lahars. Debris lahars are full of solid stuff like rocks and ash, while mudflow lahars are more waterlogged and sludgy. Lahars can be triggered by the rapid melting of snow or ice, heavy rain falling on loose volcanic material, or even a crater-like eruption. The volcano's characteristics and presence of water are key factors in how lahars form and move downhill. When lahars come barreling down mountains at speeds of up to 120 miles per hour, carrying loads of debris, it's a recipe for disaster. Unless you have a surfboard, but I doubt you'll have a surfboard on a volcano. Just saying. Also, it won't work. Going to the beach for a sunny vacation is the best. There's nothing like basking in the sun, feeling sand between your toes, and hearing waves crash against the shore. But even though it's all relaxing and picture perfect, always keep an eye on the water and never turn your back on the ocean. You may know about rip currents and tides, but have you ever heard of square waves? It's a real thing, and it can be pretty scary. Square waves, also known as cross seas, happen when two swells meet, forming a unique square pattern that looks like a checkerboard. They can be found along coastal areas, and while they are rare, they can create waves up to 10 feet high and make it tough for boats and swimmers to maneuver. If you find yourself in the water with square waves, you might feel like you're fighting against two different currents. The best thing to do is to not go too far out to begin with, and get out of the water as soon as the waves become too strong. Square waves are more dangerous for boats and ships, so it's best to stick to the shallow waters and stay safe. Whirlpools and maelstroms are powerful natural forces that have scared sailors for years. They happen when certain weather and current conditions come together just right. Most of them are safe if you stay away, but let's see what they really are and how they form. A whirlpool is basically water that starts spinning when two currents meet, or one current hits something solid like a wall. They can be big or small, depending on the speed of the water and waves. Most aren't dangerous, but there are also maelstroms, which are large, forceful, and violent whirlpools, caused by ocean tides and narrow straits. Tidal currents in places like Norway's Saltstraumen and Moxstraumen can create massive whirlpools. Scotland's Corryvreckan whirlpool is one of the world's largest. Other examples of whirlpools can be found in Japan, Canada, and New Zealand. Are they portals? They're definitely not portals. Researchers have recently looked into ancient underwater volcanic eruptions and how they affected Earth's climate. They studied materials from Bronze Age eruptions to learn more about their scale, dangers, and impact on climate. For example, one eruption about 3,600 years ago in the Aegean Sea caused chaos in Santorini. The study focused on this event to understand its importance. By analyzing volcanic deposits, the researchers gained insights into how future eruptions could affect climate. They discovered that sediment waves from shallow underwater eruptions could lead to tsunamis and impact the ocean floor. These findings help us understand how underwater volcanic eruptions relate to the marine environment, which can help us predict climate changes in the future.
A tsunami hitting major cities on or near the Mediterranean Sea and in the northeastern part of the Atlantic Ocean is not a matter of if, but when. It is scary and surreal to think that places like Cannes or Barcelona could suddenly get slammed by a huge wave. But the fact is, European coastlines are in active tectonic areas. Only about 10% of all tsunamis worldwide happen in the Mediterranean, and there have been at least 290 tsunamis in this area since 1600, before Common Era. Despite the relatively low number, this phenomenon has caused numerous devastating disasters throughout Europe's history. Back in 1755, an estimated 8.5 magnitude earthquake with an epicenter southwest of Cape St. Vincent, triggered a tsunami that destroyed most of Lisbon, the capital of Portugal. About 40 minutes after the earthquake, this massive wave just slammed into the harbor in downtown, racing up the Tagus River. The phenomenon was so fast that several people on horseback had to gallop to higher ground to avoid getting carried away. And this was just the beginning of a nightmare, with 2 more terrifying waves hitting Lisbon right after. A disaster like this is similar to what we see in the Pacific Ocean several times a century, but in the Atlantic, it's very rare. This type of major tsunami is expected to happen every 3 to 5 centuries, but now it could happen tomorrow. Marseille in France, Chipion in Spain, and other cities are on the list of important locations that could be flooded soon, with a roughly 100% chance of being hit by a tsunami in the next 30 years. Statistics show that the wave will probably be more than 3 feet high. I know, it doesn't sound like much, especially since when we think about tsunamis, we imagine terrifyingly tall waves, like the one that hit Lituya Bay in Alaska. In that case, the wave was over 1,700 feet tall. But we must remember that even waves only 19 inches high can be dangerous to swimmers, because it's not the height of the tsunami that matters, but also the flow and movement of the water. Not to mention the flooding, which can damage beaches, harbors, and streets. If the coastline has a small harbor and the waterfront is exceptionally low, like Cannes, this natural disaster might be much more dangerous. Tsunamis around 6 feet high can lift cars off the ground, while smaller waves can create walls of water traveling at 40 miles per hour. Plus, there are these smaller events that might not wreck everything, but still can cost a ton of money. For example, large sandbars that move around on the ocean floor, like sand dunes shifting in deserts. They can mess up pipelines or deep-sea cables for internet and communications, and that ends up costing businesses and governments millions of dollars. That's why organizations like UNESCO are worried about the possibility of a dangerous tsunami hitting Europe soon. So they're doing everything they can to prevent apocalyptic scenarios, like what happened in 2004 when an earthquake off the coast of Sumatra, Indonesia, caused waves over 100 feet high in coastal communities, resulting in over 200,000 lives lost. And let's not forget about 2011, when an earthquake off the coast of Tohoku, Japan, triggered a tsunami that reached about 6 miles inland and caused a major nuclear accident at a power station along the coast. Over 16,000 people lost their lives in that tragedy, and the event resulted in billions of dollars in infrastructure damage. These disasters were huge wake-up calls, and we've come a long way since 2004. We're much safer today, largely because the tsunami warning system is highly effective at quickly detecting this dangerous situation. Unlike many other natural phenomena, a tsunami can be anticipated. We may only have a few minutes to act, but if we all know what to do, many lives can be saved. And in most parts of the world, sirens are commonly used to alert people to tsunamis. To sound the siren as early as possible, initial tsunami alerts usually rely only on seismic data. First, specialists receive information about an earthquake. Seismic waves travel about 100 times faster than tsunamis, so they have enough time to analyze the data and see if the earthquake might have generated a tsunami and whether they should issue an initial tsunami alert. At U.S. warning centers, for example, scientists typically issue initial alerts within 5 minutes of an earthquake. If a tsunami is suspected, these alerts may also include information about wave arrival times, recommended actions, and potential impacts. But sounding the alarm is not enough. To save lives, coastal communities also need to be trained to respond fast and in the best way possible. That's why UNESCO produced this program called Tsunami Ready, aiming to train people living in coastal areas at risk on how to act in case of a tsunami event by the year 2030. The idea is to help communities stay safe by teaching them how to protect their livelihoods and safeguard their homes. Being recognized as tsunami ready by UNESCO doesn't mean a community is tsunami proof, of course. It's more like a recognition that they have adopted all possible measures to mitigate tsunami risks. So authorities are helping communities to prepare themselves by installing evacuation signs, establishing security procedures, and creating plans to warn tourists. like Spain, which distributed tsunami warning signs along the entire coastline, as well as signs showing evacuation routes to higher ground. And Spain better be prepared. I mean, only 7 tsunamis have hit the country since the year 365, so it's difficult to predict the effects of such an event. But they could be devastating, considering that Spanish coastal areas are so economically important. There's also a danger zone in the Averroes Fault beneath the Barents Sea. If an earthquake happens at this point, people will have only 21 minutes to escape a tsunami. UNESCO has also established 12 tsunami warning centers, which cover Europe as well. This initiative involves 5 centers located in the Mediterranean and Northeast Atlantic regions. These centers can save thousands of lives because they monitor ocean disturbances 24/7. Then, after analyzing the threat, they send out messages based on the event's potential to cause a tsunami. The intensity scale ranges from no effect to completely devastating. And by that, they understand that nearly all brick buildings could be demolished by waves, and even the most reinforced concrete structures could suffer heavy damage. Now, so far, we have mostly talked about tsunamis caused by earthquakes along converging tectonic plate boundaries. In fact, earthquakes have accounted for over 80% of tsunamis since 1900. But tsunamis can also result from landslides, volcanic eruptions, and even meteorite impacts. Experts are also worried that with the current changes in climate, we might see more of meteotsunamis popping up in the Mediterranean. These ones are triggered by freaky weather conditions and can mess with any coastline that's got a shallow seafloor. They might not be as huge or famous as the earthquakes ones, but they can still cause significant property damage and put people in danger. For instance, in 2006, a meteotsunami struck the harbor of Ciutadella on the Spanish island of Menorca. Yachts were tossed into each other and later stranded on the harbor floor as the water receded, resulting in tens of millions of euros in damage. Unfortunately, meteotsunamis in the Mediterranean tend to be stronger during summer, so if you're planning to spend your vacation in Europe, stay alert for any signs of dangerous waves. If you suddenly encounter a tsunami moving in your direction, remember this is the time to react. Move to higher ground as far inland as possible. Pay special attention to any emergency alerts and information, and follow the guidance of local authorities. Most importantly, do not wait around taking photos. Leave the area as soon as you notice any signs of this danger event, or if you hear an official tsunami warning. Hey, stay safe.
There's a place on Earth so dangerous that even the most fearsome creatures of today wouldn't last a moment there. It used to exist in what we now call southeastern Morocco, the land called the Chem Beds. The story of this place stretches back to the Cretaceous period, about 100 million years ago. It might have looked like a beautiful place at first sight, a lush green forest, rivers glittering in the sun, until you meet some terrifying dinosaur. The lions or sharks of today are nothing compared to what the fossils show us. The Chem Beds were dominated by terrifying predators, and above them all, 3 of the largest predatory dinosaurs ever discovered. For example, Spinosaurus. This dinosaur was unlike anything you can imagine, a half reptile, half monster standing over 50 feet tall, bigger than a T-Rex. This hybrid with a crocodile-like snout and a sail on its back hunted the forests. But this dino could dive into the rivers, so not even waters were safe from it. It could catch huge fish, as if plucking them from the shallows. There was also Carcharodontosaurus, a carnivore with the name that literally means shark-toothed lizard. Its razor-sharp teeth could slice through flesh with terrifying ease. This monster stood almost as tall as a house and was faster, stronger, and more aggressive than nearly anything that had ever walked the earth. There was also Deltadromedus, a raptor-like dinosaur built for speed. It was a quick-moving ninja that stalked its prey with horrifying precision. Oh, and the skies were a fun place too, with all these pterosaur creatures flying around. These guys are often mistaken for flying dinosaurs, but they were actually a different kind, more like close cousins of dinosaurs. These majestic reptiles soared above the Chem Beds, and had wingspans that could stretch up to 30 feet. The fingers were feathery, with a fourth finger kinda like bats. They could glide through the air so easily thanks to their super light skeleton. But it wasn't just the dinosaurs that made the Chem bed so horrifying. The waters also hid their own dark secrets. They were home to giant, terrifying fish and crocodile-like creatures. Their jaws were strong enough to crush bone, and they were lurking beneath the surface, waiting for anything unlucky enough to stumble into their path. One of the river creatures was Sarcosuchus, also called the super croc. Being about 40 feet long, it could easily swallow an adult human. Or better yet, it could take on a full-grown dinosaur and win. Its jaws snapped with unimaginable force, and no creature, not even Spinosaurus, was safe from it. Coelacanths could also hang out in the rivers. It was a monstrous predator that could easily swallow a huge fish whole. They had these creepy, icky fins that moved in a way similar to how human arms and legs move. And they could also kind of raise their heads like humans because of a special joint in their skull. Ew. Fun fact, we thought these monsters had gone extinct 60 million years ago, together with dinosaurs. But recently, we rediscovered them living and thriving in the Indian Ocean. Turns out they were just hiding in the deep waters. They probably didn't even notice the dinosaur asteroid or humans at all. Yay? Don't worry, over millions of years, they became basically harmless. They got 4 to 5 times smaller, even though they still weigh about 200 pounds. Just imagine what they were like back in the day. Chem waters were also home to giant lungfish and other creepy aquatic creatures. So you couldn't even drink or take a swim safely without getting bitten by something. Whew, what a place. Even turtles there were the size of cars. Imagine trying to survive in a world where creatures like this are literally everywhere. And I mean everywhere. This place was unique not because huge beasts lived there, but because of the sheer number of predators. You might think, it shouldn't be that easy for all these predators to hang out in one place, right? And you're right. Seems like prey was scarce there. That's even more chilling. All the predators just wandered around, hunting whatever meager life remained. And if there's none, then fighting each other. For years, scientists have wondered why it was the case. Maybe that's just how life was back then. And all corners of Earth were crazy like that. Or is there something special about this place? Some even say that maybe it's just because we only found predators' fossils, while normal friendly animals have disappeared, and that the fossil record might be skewed. But who knows? And the environment itself was just as fascinating as the beasts who lived there, just a bit more friendly. It's hard to imagine, but back in the day, this desert was a green paradise, humid and full of rivers. The heat of the sun scorched the land. The climate was hot, so hot that even the poles were warm. The weather there was extreme. Dry seasons followed by intense storms, which shaped the land and life. The giant rivers carved their way through this landscape. They stretched from the Sahara, emptying into the ancient Tethys Ocean to the north. If you were there, you'd see vast, interconnected basins, and beyond them, the central Atlantic Ocean. The floodplain stretched out beneath a sweltering sky. The rivers were just as wild as local animals, flowing lazily one day, but raging like furious beasts the next. At first, these rivers were powerful, carving deep channels through the land and creating wide sandbanks. But over time, they slowed down, and the landscape changed into shallow ponds and salt-covered flats. As water gradually faded away, it left behind a patchwork of wetlands and slow-moving waters. Right now, the Chem Beds is a vast, rugged desert where time has stood still for millions of years. If you visited it, you'd see a giant escarpment, its rocky face winding along the border of Morocco and Algeria, bathed in the sun's harsh light. Beneath your feet would lie layers of fossilized history, That's one of the reasons why scientists were long fascinated with this place. It must be one of the most comprehensive collections of fossils ever discovered in northern Africa. There are fossils from other parts of Africa, of course, like Egypt's Bahariya Formation. But they don't tell us much about life during this time, not like Chem. That's all because those rivers we mentioned in hotter and drier places, they've eroded or still remain buried under the sand. The first discoveries from Chem began in the late 1940s. A scientist named Schubert uncovered bony fish fossils among the escarpment near the Morocco-Algeria border. Just a few years later, a paleontologist, René Lavocat, took things to the next level. Traveling by camelback, he scoured the desert landscape and uncovered a real treasure trove of fossils. He found the partial skeleton of a massive herbivore dinosaur. Finally, at least one peaceful creature in the Chem beds. This long-necked giant roamed the ancient river valleys and ate leaves like a good boy. For the next several decades, scientists only did small-scale fossil hunting expeditions to this place. There were modest discoveries made here and there. Then, in the 1970s, German paleontologist Helmut Alberti led his team to the Chem beds, and that's when things took a wild turn. They uncovered fossils of prehistoric fish, crocodiles, dinosaurs, and pieces of the infamous Spinosaurus. Imagine being one of the scientists on that team. They were probably jumping from excitement. By the mid-1990s, the fossil game changed dramatically. Incredible new species were identified from the Chem beds. Over the years, the discovery pace has only accelerated. Paleontologists, armed with new tools and techniques, have uncovered more fossils than ever before, and there's only more to come. The Empire State Building's tower was designed to serve as a docking station for dirigibles. At that time, people believed that these airships would become the main means of transportation in the future. The project included gangplanks, check-in and customs offices, and so on. But then the engineers realized that the wind up there was too strong for their plans, and they gave up on their idea. Angel Falls, the largest uninterrupted waterfall on the planet, is more than twice as tall as the Empire State Building. During the dry season, the falling water sometimes evaporates before it reaches the ground. One of the most mysterious sounds ever heard on Earth was the bloop. It occurred in 1997 and resembled the noise of marine animals. But the volume was too great for a sound produced by a living creature. The bloop continued for 1 minute. It started from a low rumble, and then rose in frequency. Antarctica might just look like a giant field of ice, but there's actually a huge continent underneath. That means that it has volcanoes, mountains, and valleys, like any other continent. Scientists have recently discovered that the Antarctic landmass has the lowest point on the planet, as well as huge mountain ranges. If any of the numerous volcanoes were to erupt, it would melt a huge part of the surface ice and increase the spill of ice into the ocean. The sea level would rise and flood coastal areas around the world. The ocean waters would also be disrupted, putting marine life at risk, though all of these volcanoes are dormant at the moment. Each day on the South Pole lasts 6 months on this continent. The South Pole only has a single sunset and sunrise across an entire year. Early Earth might have been purple, not green. There's a theory that ancient microbes used molecules rather than chlorophyll to absorb sunlight. These molecules likely gave living organisms a violet tint. During the Stone Age, the entire population of Central Europe was around 1,500 people, which means they would all fit on a mid-sized cruise liner these days. Astronomers have figured out that the Milky Way weighs around 1.5 trillion solar masses, and one solar mass is the mass of our Sun. A tiny part of this weight is a supermassive black hole at the center of the galaxy, and 200 billion stars. The rest is dark matter, mysterious and invisible. If all sheets of Arctic ice and glaciers melted at the same time, the sea level would rise for the height of a 26-story building. Under black or UV light, ripening bananas look bright blue. That's because of the chlorophyll that's breaking down when the fruit is ripening. Because of tectonic plate movements, the Pacific Ocean shrinks every year, and the Atlantic Ocean gets bigger by the same amount. These days, there are only 2 ice sheets in the world left after the planet's last ice age. The first is the Greenland ice sheet. The second, the Antarctic ice sheet, is enormous. It's the size of Mexico and the continental US combined. Tsunami waves often go unnoticed. They don't rise for more than several inches above the surface until they reach shallow waters. When the ocean is deep, though, they can travel as fast as a long-distance passenger airplane. Corals that live in shallow waters produce their own protection from the sun. Without it, sunlight would harm the algae living inside them. To protect these algae, which are the main source of food for the corals, they fluoresce. This process makes proteins that act as sunscreen. Almost 90% of the volcanic activity on Earth happens in the oceans. The South Pacific has the largest concentration of volcanoes people know about. There's one volcano cluster that has 1,133 volcanic cones. All of them are active and cooped up in an area the size of New York State. The Zemchug Canyon in the middle of the Bering Sea is the largest underwater canyon ever discovered. There are more treasures and artifacts at the bottom of the ocean than in all museums in the world combined. In 1900, one of the biggest hurricanes struck near Central America and in the Gulf of Mexico. It then went as far as Florida and Texas and is considered to be the most devastating hurricane in the United States history. They first detected it on August 27th, and it lasted for many days. By the time it reached the Texas coast, the storm had turned into a Category 4 hurricane. Hurricanes are categorized on wind speed and intensity using something called a Saffir-Simpson scale. There are 5 different categories from 1 to 5, with 1 being the weakest and 5 being the strongest. The people of Galveston had less than 4 days to prepare for the arriving storm that even stretched out to Oklahoma and Kansas. The Great Hurricane then made its way to the Great Plains and turned towards the Great Lakes, New England, and reached southeastern Canada. The storm was so bad that more than 3,600 homes were damaged, even though they were sturdy enough to withstand the storm. Given the population numbers back then, it was equivalent to hundreds of thousands of houses destroyed, if not millions. Spotted Lake, Canada. They call it the most magical spot in Canada. In winter and spring, this is just a regular lake that looks like any other, but try going there in the summer when the water starts to evaporate. It'll feel as if you've entered a different world, a polka-dotted landscape with blue, green, and yellow spots. Over the summer, there are over 300 pools there, and they all look magical. Over the centuries, people believed each of them had different healing properties. Oh, and the explanation for the vibrant colors is pure science. Each of them has a high concentration of different minerals. We live inside the sun. Its atmosphere stretches far beyond its visible surface, and even though Earth is 93 million miles away from the star, it's still within reach of the sun's atmosphere. Auroras happen when charged particles from the sun get caught by Earth's magnetic field and crash into the upper atmosphere near the poles. Our planet is gradually slowing down the speed of its rotation. It happens at an unhurried pace of 17 milliseconds per 100 years. Because of this, our days are becoming longer, and still, only after 140 million years, a day on Earth will last 25 hours. Earth's southernmost continent, Antarctica, is only the 5th largest one, but it contains almost 70% of the planet's fresh water and 90% of the world's ice. Antarctica is also considered to be a desert. Lots of rocks on Earth have a Martian origin. Scientists analyze the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places. It turned out that these rocks had arrived from the Red Planet. The largest sandcastle in the world is located in Denmark. 30 sand sculptors who created it used more than 5,000 tons of sand. To make it more durable, they added 10% of clay, together with a layer of glue. They built it to stand tall against long and stormy winters. Some photons that don't get absorbed are re-emitted, and their wavelength determines the color we see. When you expose a material to sunlight or photons of higher energy, it can damage its chromophores, which is why they won't be able to emit photons at certain wavelengths. Red materials fade in sunlight the most. Their chromophores emit red light in a way they mop up photons of the rest of the wavelengths. From 60 to 100 tons of space dust drift down to our planet's surface every day. These tiny cosmic particles are mostly released by comets, which are usually made of dust and ice. When the sun turns this ice into vapor, the remaining dust travels down to Earth. Scientists discovered something Atlantis-like near Australia. There used to be an entire continent that's now underwater. Here's what happened to it. Around 70,000 years ago, during the last ice age, there was a huge landmass called Sahul. It was located in the southwestern Pacific Ocean. This ancient supercontinent connected what we now know as Australia, New Guinea, Tasmania, and the Aru Islands into one giant piece of land. Imagine lush tropical rainforests surrounded by beautiful mountains. Sahul's tallest mountains were in the New Guinea highlands, with peaks reaching over 13,000 feet. This beautiful place was home to a variety of unique animals, most of which were pouched creatures. But back then, they weren't just koalas and kangaroos. Sahul was filled with different types of grazers, burrowers, scavengers, and predators. It was home to a huge diprotodon, a powerful hunter Thiosolio, and a horrifying Megalania, a creature that's much larger than any living lizard today. It was a unique place because the rest of the world was filled with placental animals at the time, like wolves, elephants, and humans. In Sahul, the only normal mammals were bats and rodents. But not all its parts were the same. The Timor, Arafura, and Carpentaria regions were covered by hot savanna and dry forests. It looked kinda like modern Australia, hot air deserts with scrubland, steppe, and temperate forests along the eastern coast. Back then, people were migrating all across the world. They made an incredible journey from Southeast Asia to Sahul and first arrived here from 60 to 45,000 years ago. They mostly traveled by foot and crossed the sea using bamboo rafts and simple boats. They came there from an ancient landmass called Sunda, which includes parts of Southeast Asia. They traveled across a series of islands known as Wallachia and eventually spread across Sahul. And it wasn't a small journey. Sahul was huge, around 4.1 million square miles. That's bigger than the USA or Canada. It stretched from the equator to around the southern part of New Zealand. So they arrived in what is now Australia and became Australia's first people. Scientists think that Sahul had a population of 500,000. We've discovered cave paintings that date back around 40,000 years. It's a hunting scene depicting an anoa, or miniature buffalo, facing figures of humans and animals. Researchers are trying to figure out how these early settlers moved across Sahul and where we might find archaeological evidence of their journey. To do this, they created a landscape evolution model. The simulation showed how Sahul changed between 75,000 and 35,000 years ago. It showed potential migration routes and archaeological sites. Humans likely traveled along coastlines and rivers. But how did Sahul get submerged off the coast of Australia, similar to the mythical Atlantis? During the last ice age, much of the Earth's water was locked up in large ice sheets and glaciers. The sea levels were much lower than they are today. After that, the global temperatures increased. The ice sheets melted and the sea levels rose, flooding the land bridges that once connected different parts of Sahul together. About 8,000 years ago, New Guinea separated from mainland Australia, and then, about 6,000 years ago, Tasmania did the same. We still can explore the underwater parts of Sahul thanks to new technology. Divers explore and collect samples directly from the ocean floor. Underwater drones can go to places that are too deep or dangerous for humans to explore. And with sonar mapping, scientists use sound waves to create maps of the ocean floor. It's like using an echo to see what's underwater. The sound waves bounce off the seabed and come back, helping us create a picture of what it looks like. Deep underwater, archaeologists have found stone tools and other artifacts. They also discovered fossils of animals like Diprotodon and Thylacoleo. By studying the underwater terrain of Sahul, they learned about the ancient rivers, lakes, and coastlines that existed during the Ice Age. But Sahul isn't the only underwater continent. Sahul isn't the only hidden gem of Southeast Asia. Take Sundaland, a place made up of Sumatra, Java, Borneo, and some other islands. This place was crazy huge during the Ice Age, but now almost fully underwater. Almost, but not entirely. The parts above the ocean are teeming with life. If you like birds, check this place out. It has almost a fifth of the world's bird species. You can spot colorful birds like the Java hawk eagle and the Bali starling among the lush forests. It's also a home to a fourth of Earth's fish species. Sundaland's waters are a haven for marine life, even the most exotic animals like the Asian arowanas. It's also a treasure trove of flowers. That's where you can find Rafflesia and Titan arum, the world's largest flowers. This makes it very similar to Zealandia. Zealandia is a long, narrow piece of land about half the size of Australia. It broke from Antarctica about 100 million years ago. Just like Sundaland, it isn't fully underwater. 7% of it stayed above sea level. This sticking out little piece is what we now call New Zealand, along with Stewart Island and some smaller islands. These pieces of Zealandia are lush and warm. They're packed with volcanoes, mountain ranges, beautiful natural geysers, and hot springs. Local people, Maori, use these hot springs for cooking. People place corn, eggs, and vegetables in baskets and lower them directly in the hot springs. Sometimes they cook food in a pit oven using heated rocks. Another hidden world is known as Argoland. This mysterious landmass was once part of Australia, back when dinosaurs chilled around. It drove scientists crazy for decades. They knew it existed because it left a huge stretch on the ancient seafloor, the Argo Abyssal Plain. About 155 million years ago, it broke off from Australia, saying bye-bye. The continent drifted somewhere north, and when it reached Southeast Asia, it just vanished. Scientists had no idea where it went, but recently they finally found its remains. Turns out, poor Argoland's lower parts started drowning into the Sunda Trench, a horrifyingly deep oceanic pit. The Earth's crust sunk into the mantle. Meanwhile, the upper parts of Argoland were pushed upward, grabbing the younger rocks on land. Because of this, Argoland broke apart into a bunch of smaller pieces. These pieces formed parts of Borneo, Java, Sulawesi, and other regions. The remains are buried under Indonesia and Myanmar. Imagine a colossal landmass the size of Greenland, Greater Adria. Its journey began about 240 million years ago when it broke away from the supercontinent Gondwana. It started moving north, and after 100 million years of enjoying the warm seas, it suddenly crashed into Europe and shattered into pieces. Most of these pieces went deep into the Earth's mantle, but some were scraped off and became part of mountain ranges like the Alps. Today, the remnants of Greater Adria are scattered across more than 30 countries, from Spain to Iran. That's why they're hard to look for. Seychelles was also once part of Gondwana. Yep, these idyllic islands are sitting atop of the ancient continent. We know a lot about it because of its fascinating granite outcrops. 100 years ago, Alfred Wegener discovered continental drift, but no one believed him. These granite outcrops helped him prove that he's not crazy and that tectonic plates really are moving. The Seychelles broke off from India and Madagascar and eventually became a sad loner in the Indian Ocean. This probably happened because of some insanely active volcanoes in the Deccan Traps. But now, the islands are home to unique species both on land and in the coral reefs nearby. Mauritius broke off from India after the dinosaur wiping. Along its journey, it stretched into a long ribbon-like shape and also broke into pieces. Now it's all scattered beneath the Indian Ocean. Scientists stumbled upon this lost land by studying tiny ancient crystals called zircons. These zircons are like time capsules. They date back an astonishing 660 million to 2 billion years. That's even older than Mauritius itself. These ancient crystals hinted that there's another Atlantis somewhere nearby. Turns out there are hidden continents all around the world, and maybe we'll discover more of them in the future.
On January 14, 2022, residents of Anchorage, Alaska heard a series of loud bangs. They didn't stop for a half an hour. As they found later, the source of the bangs was almost 6,000 miles away in the Tongan archipelago in the southern Pacific Ocean. The Hunga Tonga underwater volcano abruptly woke up from its sound sleep. It last erupted at the end of December 2021 after several years of inactivity. Hunga Tonga sent a large plume of ash into the stratosphere that was seen in the capital city of Tonga, 43 miles away from the volcano. In the following days, it was emitting steam and gas to the height of 7 miles. Plus, it was letting out ash that accumulated next to it and even made the island on which it was standing increase in size. Then, it went back to sleep, and the officials even announced it was dormant. But just a couple of weeks later, it woke up again with a crazy force. It sent ash clouds 12 miles into the atmosphere. It blocked the sun in some places and rained down from the sky. The sound waves from the eruption traveled around the planet several times. People in Fiji heard a sound that reminded them of thunder. Some booms even reached Canada. Shockwaves went around the Earth 4 times in Japan and Utah, and at least twice in Massachusetts. The eruption caused tens of thousands of lightning flashes. It also triggered a mega tsunami hundreds of feet high. It caused damage to buildings and infrastructure, such as underwater cables. The extreme waves traveled all the way to the California coast, and there was an unusually high tide along the Pacific coast of Canada. Scientists studied seismic data to understand what caused such a massive eruption. Their research model showed that there was a big blast, likely because gas got trapped in rocks, like how a pressure cooker works when it's overcooked. This blast released a huge amount of energy, as much as 5 of the biggest underground nuclear tests. It all happened under a shallow part of the sea, where gas-filled rock was trapped. Now, normally when a volcano erupts, the fumes cause a temporary cooling effect on the Earth's surface. But Hunga Tonga's eruption was different. It didn't produce many fumes, but released a massive amount of water vapor, equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned vast amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its long-term effects on our weather patterns. This is because the only way to measure stratospheric water vapor is with special satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. In fact, the Tonga eruption is the most well-recorded blast of its kind in recent history. Scientists had lots of tools to study it, like satellites that took pictures from space and sensors that listened to the vibrations and movements in the Earth. There was a similar eruption in 1991 at a volcano in the Philippines, but back then, they didn't have as many advanced tools as they do now to study it closely. Experts from different countries looked at satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and of course, what this would mean for the planet and for all of us. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. But Hunga Tonga ended up with just a minimal effect on global average temperatures, at least for now. Let's just hope it won't repeat the story of Mount Tambora volcano in present-day Indonesia. Over 2 centuries ago, in 1815, this bad guy interrupted and caused the year without a summer. In the following year, the winter was unusually cold and wet across Europe and North America. There were also some catastrophic tsunamis, destroying homes that took 10,000 lives and 80,000 more who fell ill in the aftermath. Now, you can't miss an event like Hunga Tonga or Tambora eruption, but some underwater volcanoes are discovered by accident. A passenger on a commercial flight looked out her window above the Pacific Ocean and saw a weirdly colored patch on the water. She thought it could be an oil slick or a floating pumice raft, which is a telltale sign of a recent volcanic eruption. She decided to send a photo of this scene to a geologist. And that's how scientists found one of the largest volcanoes in the world, Havre. It's hiding about 3,000 feet below the surface. In 2012, Havre had a massive eruption that lasted about 90 days. Hot lava poured out of 14 different vents around the volcano's semicircle-shaped opening. Havre is just one of many volcanic systems covered by thousands of feet of water. These volcanoes are the most active on Earth and are part of a giant system called mid-ocean ridges that stretches around the world. This system produces about 75% of all the magma that comes out of Earth's volcanoes each year. It releases over half a cubic mile of lava. When the magma cools down, it forms the edges of new ocean plates, which are like giant puzzle pieces that make up the Earth's crust. A team of scientists studied material left on the ocean floor by volcanic eruptions from the Bronze Age. About 3,600 years ago, a volcano that was partly underwater in the southern Aegean Sea woke up with a bang. This eruption destroyed the island of Santorini and sent massive amounts of ash, rocks, and gases into the air. It left behind thick layers of ash and rock that settled in piles on the ocean floor. Scientists have been studying the ancient Santorini eruption for several years to figure out what happens during such massive ones. Their research helps explain how future volcanic eruptions could affect the weather on our planet. The study also helps scientists understand the strength of the eruptions, how high the eruption columns might go, and the sizes of the waves that form when all that ash and rock settles into terraces on the ocean floor. This information will help predict the dangers of future eruptions. Now, when a volcano erupts, the last place you want to be is inside it. But scientists did it for you. Well, kinda. They produced a smart new imaging technique that uses the best ideas from medical imaging and optical telescopes. Matrix imaging, that's what it's called, makes it easier to understand what's happening underground, even when there aren't many sensors available. These sensors, called geophones, detect and record the movement of seismic waves, which are vibrations that travel through the Earth. By studying these waves, scientists can learn about the distinct types of rocks and how they are arranged beneath the surface. The researchers test their method on a volcano in Guadalupe in the Caribbean Sea. There aren't so many geophones on this site, but the scientists combined the data from multiple geophones thanks to this new tech. They used a special trick called the memory effect to reverse the distortions that happen when seismic waves bounce off different underground materials and figure out what the original signals look like. The researchers could clearly see the structure inside the volcano down to a depth of about 6 miles, with incredibly detailed images in a resolution of over 300 feet. They found out that there are many layers of magma stored underground. These layers are connected to other deep parts of the Earth. Knowing about these layers and how they work could help scientists make better guesses about when a volcano might erupt. If they can do that, they might be able to warn people earlier and keep them safe from dangerous eruptions.
Around 3 to 200 million years ago, all the continents were stuck together as one big landmass. Over time, they moved apart and formed the continents we have today. That giant landmass was called Pangea, and the Earth looked very different back then. Which begs the question, what would our life be like if that split never occurred? Well, let's find out. In simple words, tectonic plates are big chunks of the Earth's outer shell. Our planet is like a puzzle of landmass, and these plates are the pieces. Since the Earth is so incredibly hot inside, its heat influences the rocky ground above the core. Slightly melted rocks start floating in the ocean of scorched magma. This movement creates the tectonic plates, and they're always moving, just really slowly, which is why we don't notice it. Their movement has been a fundamental force shaping the Earth's surface, climate, and the evolution of life over millions of years. For example, when two plates bump into each other, one might go under the other, or they might slide past each other. Sometimes they pull apart. All these movements create things like earthquakes and volcanoes. And when plates push against each other, it can make the land go up, creating mountains. So, the big mountain ranges on Earth, like the Himalayas, formed because tectonic plates were pushing into each other. Now, here's the thing with Pangea. In a supercontinent, all tectonic plates are united, and they don't really move. Well, at least not a lot like they do now. So if Pangea remained intact for billions of years, everything in our world would look completely different. For example, we wouldn't have many mountain ranges anymore. No Alps, Himalayas, and Andes. What a nightmare that would be for ski lovers. But there's an upside to that too. No continental drift means much less disasters in our world. All our earthquakes, tsunamis, and volcanic eruptions would be much rarer and calmer, or might not occur at all. However, hurricanes would keep existing, and they could be crazy strong. With Pangea being one huge lump of land, the rest of the world will be water stretching from the west to east. That's just a free water slide for a hurricane. Please feel free to build up in intensity without anything to bump into. So once it finally reaches us, prepare for Category 5 or even stronger hurricanes or tornadoes. They'd be regular visitors too. And if you decided to live in Eastern Pangea, yep, you're doomed. The way the continents are arranged also affects how the oceans move and the weather behaves. In Pangea, the climate would be very different across the globe. The middle of our supercontinent would be super weird. Right in the center, we'd have a huge dry desert. But there would also be dense, cool rainforests along the borders of this desert. Why? Because Pangea is so massive and rain from the ocean wouldn't reach far enough inland, so it would be stacking up around the edge. This would make some parts of the land not so great for anything. Rain and water would wear down the land, flattening hills and carrying away soil over a long time. Eventually, Pangea might even shrink and disappear underwater. Closer to the edges of Pangea, the weather might be more mild or tropical. Up north, it would be warmer than it is now. And finally, we'd have some understanding of seasons, but we'd have no idea that it becomes harder for you to breathe as you go higher. So, how would all this affect living things? Well, bad. Pangea would be awful for the variety of life on Earth. History shows that having separate pieces of land is very important for life. It was a big reason why new kinds of species appeared. For example, Madagascar, an island that broke off from Pangea, was isolated for millions of years, which is why it has many plants and animals not found anywhere else. Fewer isolated lands like Madagascar and Australia mean less cool and unique plants and animals. The climate problem doesn't go away either. Almost all Pangea would be hot and dry inside, but it wouldn't be all too boring. There would still be some environments for animals to live in. Reptiles like dinosaurs might do well in this kind of climate. That's one reason why dinosaurs thrived when the whole world was one big landmass before mammals came around. Also, this might push for the development of creatures that can live in water. They'd be more diverse and bigger in size. So basically, Pangea is a master of creating Earth as dangerous for humans as possible. With all this in mind, let's finally see how humanity's doing, assuming that we survived and evolved. First of all, where would your country be located? In theory, you could take a road trip from Brazil to Canada, because they'd be part of the same huge landmass. North America would be right here, and Europe would be just east of it. Most of Asia would be up north, and Antarctica would stay down south. Australia would still be in the middle of nowhere. A literal Antarctica would be closer to everyone than Australia. That's assuming that countries stayed the same. And hey, cool news, all our modern countries might not exist at all. Okay, that didn't sound as good as intended. More precisely, the countries would have completely different boundaries, and the world would be much more peaceful and united. Let's see. First, we'd form some tribes. But since we would share the land, we'd have to compromise. We can't all have the only coast or only inland regions. Each tribe would probably get a fair piece of the land so that everyone could meet in the middle to settle problems or make trade agreements. As tribes got bigger, people would move to new lands, separated by deserts and forests, forming their own nations. The hunter-gatherer era might take some more time, since we have fewer animals and plants. If we started hunting, we'd probably wipe out all the big animals pretty quickly. Except for the ones we could potentially domesticate. Imagine having dinosaurs as pets! But the whole supercontinent would quickly enter the agricultural era, because whatever technologies we discover, we'd share them with each other right away. The main difference would be that during our age of exploration, there would be mostly small, isolated islands to discover. Travel and trade would be easier too. Cultures would be less distant from each other compared to our world. For example, right now, Native American culture is very different from Pacific Island culture because they've been separated by water for a long time. But on Pangea, cultures might form a continuous line from the southern tip to the northern tip, which means all cultures would be very closely related. And that wouldn't be the only similarity. Our appearances would be very much alike as well. Since Earth is still tilted on its axis, the very north and south will stay cooler. So even though some people would still have white skin and blonde hair, in general, everyone would still have less melanin. Around the central part where the sun is always shining, most people will still have dark or tanned skin. This could create a more similar world where people could see themselves as global citizens and Earthlings. The sad part is, we probably wouldn't be as motivated for technological progress as we are now. All the land is already known. There's no need to explore. The weather is mostly good and warm. The crops are growing well, the neighbors are hopefully peaceful, which is why humans would be fine with things as they are. We'd probably stick to basic tools and science. Of course, we're naturally curious creatures, so we'd still have some progress. It just would be very slow compared to our world. What sounds boring for some might sound awesome for us. Our life would be less exciting, but we'd be more united and peaceful. Maybe, in a world like that, we learn to treat each other with more kindness and love. But we can only imagine.
So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas Fault Line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas Fault Line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tejon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide. that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the US around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis. But there's something that can cause more damage than the big one. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas fault line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, they can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put 2 and 2 together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed, but Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe.
See how the Antarctic Peninsula looks just like South America, but upside down? This isn't just a coincidence. It's the ghost of a 30-million-year-old breakup. These continents were once connected, but their divorce gave birth to an ocean current so powerful it was capable of completely freezing Antarctica and shaping its landscape. Here's how it went down. Tectonic plates pulled a sneaky move and cracked open a ridiculously narrow passage in the ocean, about only 500 miles wide, forcing 4.5 trillion cubic feet of water to flow inside this geological straw. This was the birth of an ocean current stronger than the Amazon River. This ocean current, called the Antarctic Circumpolar Current, by the way, flows in a circular motion, going clockwise because of the strong winds that blow over there. This circular motion around Antarctica caused erosion, shaping the landmass of the continent into a circle, except for that stubborn peninsula, which is being slowly dragged east like a kid refusing to leave a playground. Wait, South America and Antarctica used to be one? Yep, a long time ago. South America, Australia, and Antarctica were all part of a supercontinent called Gondwana, which also included Africa at some point. Back then, South America and Antarctica used to be basically joined at the hip by a land bridge called the Antarctic Land Bridge, which just so happened to be a lush green forest and also a great dinosaur highway. Yeah, you heard it right. Dinosaurs. A 95-million-year-old dino, whose name I can't pronounce, sorry, was discovered in Australia, and scientists found out it had actually been a distant cousin of Argentina's Sarmientosaurus. Same jaw, same chiseled teeth, same everything. These guys were like identical twins, separated by an ocean. How? Because back then, Antarctica wasn't a frozen wasteland. It was a temperate rainforest, like Oregon, making it a pretty nice travel route for a dino family. But the land bridge wasn't just for dinosaurs. About 40 million years ago, the ancestors of Australia's marsupials waddled to the land down under all the way from South America, taking the Antarctica route, another proof that these continents used to be connected. Things remained somewhat peaceful for the dinos and the marsupials until Earth's ground started moving. This is what a German scientist called the continental drift theory, back in 1912. Our German friend here basically looked at the coast of South America and went, "Hey, this looks like it could fit into the coast of Africa." Like a scientific Sherlock Holmes, he noticed what others had overlooked for centuries. The continents were clearly pieces of a larger puzzle. And he was right. Here's the deal. Planet Earth is made of many layers of rocks and metals, like a cosmic onion. The outermost layer, the lithosphere, is divided into pretty solid tectonic plates that move atop a layer of softer, somewhat molten rocks, like slippery ice. This is why the plates move. In fact, they've been rearranging Earth's face for billions of years, with supercontinents forming and breaking apart in cycles, like a slow-motion game of bumper cars. This movement might be pretty slow since most tectonic plates only move 0 to 3.9 inches every year, except for the Nazca Plate, racing ahead at 7.8 inches, about as fast as your hair grows. But don't let their snail's pace fool you. These shifting slabs are the ultimate planet shapers. Their slow dance gives us everything from earthquakes that build mountains like the Himalayas, to rifts that birth oceans like the Atlantic. All because the oceanic crust is dense and sinks like a stone, while continental crust floats like a cork. It's this density difference that explains why continents exist at all. Without it, Earth would be completely covered by shallow seas. This slow-motion planetary renovation project is exactly what tore South America and Antarctica apart 30 million years ago. The plates under these continents started to drift apart in a process called crustal extension. It's like the lithosphere was pizza dough being slowly stretched until it thins and splits. As the crust stretched, it became thinner and weaker, eventually cracking like the surface of a drying lake bed. This whole thing gave birth to a new tectonic plate, the Scotia Plate, that emerged between South America and Antarctica, like a geological divorce lawyer. For a while, parts of this plate stayed above water as the last gasp of the Antarctic land bridge. It was Earth's version of that one thread still connecting your hoodie after the zipper breaks. These final connections might have persisted as chains of islands, but just like that fraying hoodie, the connection couldn't last forever. Eventually, this small but mighty plate became the final nail in the coffin of the land bridge connecting the two continents. Just like all the tectonic plates, this one was also on the move. As it expanded eastward, it opened a new passage of water called the Drake Passage, slowly covering the Antarctic land bridge with ocean water. The process was like pulling open elevator doors, at first just a crack, then wider and wider until the connection was completely broken. This geographical divorce had chilling consequences. The new Drake Passage allowed the Antarctic circumpolar current to form, creating an endless loop of cold water that isolated Antarctica, shaped its land, and even cooled the entire planet. This current acts like a wall around Antarctica, blocking warm water and invasive species while regulating global climate. Eventually, Antarctica turned into an icebox that is 98% covered in ice sheets, and that holds about 61% of Earth's fresh water. Nowadays, this continent holds the title of the windiest, driest, and iciest place on Earth. It's a frozen desert where temperatures plunge below -128.6 degrees Fahrenheit, cold enough to freeze your breath mid-air. A layer of ice there can be more than a mile thick, and it expands even further in winter to cover an area larger than the continental United States. Today, if you want to travel to Antarctica, the quickest sea route is through the Drake Passage, a 500-mile-wide body of water that is narrow enough for the winds to scream across thousands of miles, transforming into monstrous waves that can tower up to 49 feet, though calm days create waves only 13 to 16 feet high. Still twice as tall as Atlantic waves, mind you. This is probably why sailors call this stretch of ocean the Drake Shake. But tectonic movement isn't just about shifting continents. It's Earth's ultimate life support system. You see, about half of our planet's heat comes from radioactive decay in the core. Thanks, uranium-235. Something like nature's nuclear reactor. This heat is behind everything from volcanoes to the very plate motion that once connected Antarctica to South America. And it only comes out of the core because of tectonic movement. Without this internal heat engine, Earth would be just like Mars. When the plates move and release heat, they also release CO2 gases into the atmosphere, regulating the temperature of our planet. And when the plates move underwater, they take a lot of this CO2 back to Earth's interior, recycling all this gas. This is why the plates can change our air, climate, and even the evolution of life itself just by moving around. But billions of years ago, these plates were not moving around. Back then, it was like Earth was wearing a solid ceramic shell with many cracks. But even without tectonic movement, the heat managed to escape through these cracks in a process called stagnant lid tectonics, kickstarting all life on Earth. And no, tectonic movement is not a thing of the past. Earthquakes are the living proof that it is not just happening today, but might repeat again on a more dramatic scale in the future. You see, to form supercontinents like Pangea, smaller megacontinents have to dive beneath another. And scientists predict that a similar process might create a new supercontinent called Pangea Proxima in 250 million years. By then, humans might be extinct or living on Mars, but Earth's tectonic dance will continue, even without us. Not bad for something that moves more slowly than a traffic jam. Turns out, Antarctica and South America used to be BFFs before all that tectonic drama split them up, like a messy breakup that literally froze one of them out. Now, they just awkwardly mirror each other from across the Drake Passage. Classic exes.
The sea is kind of rough today. Nothing special, but still, you have that sinking feeling in your stomach. Call it a sense of foreboding. Something bad is going to happen, and then you hear terrified shouts. You turn around and see a giant wave, much higher than the one surrounding it. Is it a tsunami? That's true. When people think of frightening, destructive waves, tsunamis are the first thing to come to mind. But the one that is going to crash against your ship has a different nature. It's a rogue wave. Both tsunamis and rogue waves can lead to catastrophic consequences, but the difference lies in what causes these walls of water and where the destruction they bring about occurs. So, imagine a giant 60-foot tall wave rolling over your ship. It's a miracle that the vessel doesn't sink. This massive wave, a rogue wave, seems to have appeared out of the blue, very suddenly and unexpectedly. But however mysterious, solitary, and ominous rogue waves may seem, they're actually not that rare. Now, imagine the average room in your house. The ceiling there is likely 8 feet high. A typical 2-story house is somewhere between 20 and 30 feet high. And the Statue of Liberty is 111 feet tall if we measure it from the toes to the top of the head. Now you have something to compare rogue waves with. The largest of such waves can reach a height of 50 to 90 feet. To be considered rogue, a wave must appear seemingly out of nowhere and be higher than other waves in the area. But how much higher is still under debate. Some experts think it should be at least twice as high as other large waves in the area, while others disagree. Rogue waves are also steeper than regular waves, which normally take the form of massive swells. This allows ships to maneuver up and down such waves, even when they're really high. A rogue wave, however, looks like a wall of water, and since it's steeper than other waves, it slams into a ship with enormous force, sometimes breaking over the vessel. Another reason why rogue waves are a mystery is that no one has ever filmed the formation of such a wave and followed its life cycle. There are several photos of rogue waves, but for many centuries, the only evidence of their existence was legends and stories told by sailors who survived them. Scientists are still not sure how rogue waves form, but one theory involves wave reinforcement. It happens when two waves interact and their heights get combined. So when a 15-foot wave passes over a 30-foot one, let's do the math. It results in a short-living 45-foot wave. But rogue waves can occur not only in the ocean. On November 10, 1975, on Lake Superior, a group of 3 rogue waves, also known as the Three Sisters, might have sunk the SS Edmund Fitzgerald, an American Great Lakes freighter. The ship and the crew members were lost in the catastrophe. The waves followed each other too closely, so the ship couldn't recover and shed the water from the first wave before the following one struck. The captain of a ship that was not far from the Fitzgerald reported that his vessel had been hit by 2 30 to 35-foot waves. These waves, likely followed by a third one, then moved further in the direction of the Fitzgerald and might have caused the sinking. Now, let's wave bye-bye to that, and let's move on to tsunamis. It is an extremely dangerous natural disaster. It's very different from rogue waves. In most cases, a tsunami is caused by an underwater earthquake. Usually, when a tsunami is born, it's just a few feet high. But the closer it gets to the shore, the larger it grows. Soon it enters shallow waters and starts to slow down. The first tsunami wave crashes against the shore. Its top moves faster than the bottom, and that's what makes the wave so high and steep. The lowest point of the wave gets to dry land first. In the process, it creates a vacuum effect that pulls the water away from the coast, bearing the harbor and seafloor. Those who recognize this first sign of an approaching tsunami still have a chance to save their lives. 5 minutes later, an enormous wall of water hits the shore and wipes out everything in its way. But it's not just a single wave, there are many. This phenomenon is called a wave train. How fast this train is traveling depends not on how far it is from the source of the waves, but on the ocean depth. Tsunamis can move as fast as a jet plane in the middle of the ocean, but once they enter shallow waters, their speed drops. The first tsunami wave isn't usually the strongest, but lots of people don't know it and make the grave mistake that sometimes costs them their lives. After the first wave is gone, they relax and believe the danger is over. That's why the next waves, much bigger and more powerful, catch them off guard. Now sometimes a tsunami comes as a torrent of foaming water. At other times, it makes the sea withdraw, leaving behind stranded fish and overturned boats. Also, if you spot a slight rise in sea level, it might be the sign of an approaching tsunami. The incoming water is the first tsunami wave. The second one can be even larger, and it comes sometime later. You can also notice seawater bubbling, swirling, and creating bizarre patterns. It's another sure sign a tsunami is near. Repeated wave surges can also warn you about a tsunami. If you see unusual swells coming at regular intervals, it might be time to evacuate to high ground. Surprisingly, some of the largest tsunami waves in the world were caused by landslides. For example, a landslide in Lituya Bay in Alaska formed a megawave, one of the largest ever recorded. Its height was 1,720 feet. The mega tsunami surged over the headland, washing away trees, plants, and soil down to bedrock. The wave reached more than half the height of the Burj Khalifa, the tallest construction in the world. When a third of the East Molokai volcano in Hawaii caved in and collapsed into the Pacific Ocean, it triggered a tsunami the size of one of the tallest buildings in the world, Shanghai Tower. The wave was around 2,000 feet high. Another bizarre and dangerous ocean phenomenon is square waves. They appear when two different wave patterns crash into each other at 90 degrees. It often happens near peninsulas or land where two different seas or oceans meet. This phenomenon does kind of look spectacular, but only if you're watching it from the shore. Don't even think about getting in the water to play with such waves. Cross currents in that spot can easily pull even a skilled swimmer under the water. Square waves have caused many shipping accidents over the years, too. And if you see wild, choppy waves carrying ocean debris and seaweed, stay out of the water too. It can be a sign of a strong rip current. That can carry you far away into the ocean. And now, let me tell you about a much larger, I would even say planet-wide phenomenon called Rossby waves. There are two kinds of such waves, oceanic and atmospheric. But since we're talking about ocean waves, yeah. Slow-moving Rossby waves are totally different from ocean surface waves. They don't look like those waves that break along the shore. No, Rossby waves are giant movements of the ocean stretching horizontally across the planet. They can span hundreds of miles in a western direction and are so massive they can change the climate conditions of our planet. They contribute to high tides and even flooding in some areas all over the world. The movement of Rossby waves are complicated and depend on the location. For example, in the Pacific, waves that are closer to the equator take from a few months to a year to travel across the ocean. At the same time, waves further away from the equator often need more than 10 years to make this journey. So, as it goes by, be sure to wave.
You're chilling in Hawaii, on the island of Oahu. A friend calls you up. Hey, I'm here too. Meet me in Maui. Great, but how do you get there? Your first thought is probably to take a ferry, but that's impossible. Hawaii is a pretty unique place. It's the most expensive state to live in. It has its own official language besides English. And it's the only American state made up entirely of islands. Hawaii has a total of 137 islands. 8 are the main ones, but only 6 are open to tourists. And the distance between those islands is probably bigger than you'd expect. For example, traveling from Oahu to the Big Island is around 185 miles, which is about the same distance as Chicago to Indianapolis. You might be surprised that you can't make that trip by boat. In fact, the only ferry system that actually takes passengers in Hawaii runs between Maui and Lanai. That's it. So your only option is to travel between islands is by plane. Honestly, it's a little surprising, especially considering how many people visit Hawaii every year. Tourism pretty much drives their economy, and in the first 8 months of 2024 alone, over 6 million people visited its beautiful beaches. Knowing that, we would expect Hawaii to set up a good ferry system to make it easier for visitors to get around. Just like in Greece. This would probably boost tourism even more, bringing more money to the state. But believe me, authorities and private companies also know that. In fact, they've already tried it. Ferries were a big way of getting around in Hawaii from the 19th century up until the 1950s. Since then, there have been a few attempts to bring back a ferry service, but unfortunately, they have all failed. One of the biggest attempts was the Hawaii Super Ferry, which aimed to provide a fast, affordable boat service between islands. It could carry almost 900 passengers and even allow them to bring their own cars along. The trial run started in 2007, and people were excited, but it turned into a big fiasco. A bunch of legal and environmental issues came up, like concerns about the impact on marine life, especially whales. The courts decided the ferry didn't go through the proper environmental reviews, and that caused a lot of trouble. By 2009, after tons of protests and setbacks, they had to shut it down. If a project like this comes up again, it will probably fail one more time. And there are a few reasons why it's almost impossible to set up a regular ferry system there. Let's start by talking about Hawaii's rough waters. They are deep and wild. Take the Alenoiaha Channel, for example. It's a 30-mile stretch that separates Maui from the Big Island. Its name means Great Billow Smashing Channel, and it lives up to that. It's over 6,000 feet deep, making it one of the most dangerous stretches of water on Earth. The wind there is also super strong, the fastest in Hawaii's coastal waters. But it's not any easier in the rest of the archipelago. The whole region gets hit by storms from the Pacific up north, sending big waves crashing into the islands and making the waters rough and unpredictable. Swells can come from 3, 4, or even more directions, making the sea feel really choppy. Someone who's not used to taking ferry boats would definitely find that, well, uncomfortable, to say the least. To deal with rough seas like this, the ferries have to be really big and strong. But that also makes them more expensive and harder to run than the ones in places like Alaska or Washington State. Another reason it's so tough to set up this system today has to do with marine life. A big ship moving through the shallower waters when docking could really damage the local ecosystem. And there's also the problem that the sea routes are also the migration paths of many sea animals, like humpback whales and spinner dolphins. Not to mention, ferry services can make it easier to spread harmful plants and animals, what experts call invasive species. See, Hawaii's ecosystem is super unique because it's been isolated out in the middle of the Pacific. When we talk about plants and animals that are native to Hawaii, we mean they got there on their own, no humans involved. They arrived with the help of waves, wind, or even birds flying over. But events like these are super rare. So for over 70 million years, their plants and animals didn't have to deal with outside competition. That's made them really fragile. So, when new species get brought in by us, it can be a big problem, and they could end up harming the environment. Hawaii's already been battling invasive species like fire ants, coqui frogs, and Meconia, a fast-growing plant from South America that takes over native forests. People there worry that ferries, which carry cars and cargo between islands, could accidentally spread these invaders even more. Like we mentioned at the beginning of the video, the long distances between their lands don't really help either. For example, if you were to travel from Oahu to the big island of Hawaii by boat, it would take around 30 hours, and that's without any stops. The same trip by plane takes about 50 minutes. Ferries that cover long distances are much more expensive, so they need a much bigger demand to make them profitable. On top of that, the state doesn't really have the infrastructure, like enough ports and terminals to support the operations. So setting up new routes is pretty much out of the question. Airplanes, on the other hand, are a different story. The air travel industry in Hawaii is already well established and super competitive. That means flying is still the most practical option in Hawaii. Planes are quick, they don't make you seasick, and are pretty affordable, usually costing around $100 for a round trip. Okay, but what do the locals think about all this? Well, apparently, there isn't a huge demand for residents to commute between the islands all that often. Oahu is the busiest island in Hawaii, with about 70% of the state's population living there. It is where Honolulu, the capital, is located, and where most of the state's business happens. So, people from the other islands usually come over for a specific doctor's appointment or to catch a big concert. And that might happen once or twice a year, no more than that. So, even if people could choose between taking a ferry and a plane for these special occasions, most of them would probably still prefer flying. There are plenty of options between the main island airports. Planes usually start flying around 5 in the morning, and there are flights available every hour until the last one, which is usually at 9 in the evening. If you've been dreaming of going to this paradisiacal place but are worried about spending too much on plane tickets, I have some tips for you. First off, keep in mind that visiting all the main islands in 5 days or less is way too ambitious. So, if you don't have much time to spend there, think about your priorities. Each of the 6 islands open to tourists has its own vibe and activities. But you don't need to visit them all in one trip, and you can save some money by sticking to fewer islands. You can still explore the diversity of the islands by picking 2 that offer a nice contrast to each other. For example, while Oahu has that bustling city energy, Kauai has a much more relaxed vibe. Also, flights in the morning are usually cheaper, and it might be better to fly on a weekday rather than the weekend, although the price difference isn't usually huge. Hopefully these tips will save you some cash while still having an unforgettable island hopping adventure in Hawaii. Don't forget to share this video with a friend who's also dreaming of exploring these amazing islands. Around 5.3 million years ago, a crucial event reshaped the Mediterranean region. It was a colossal flood that refilled the local sea, which had been extremely barren and salty up until that point. It got the name Zanclean Flood, and it forever changed the geography of the area. The Mediterranean Sea is surrounded by Europe, Africa, and Asia, and connects to the ocean by the Strait of Gibraltar. This is quite a narrow passage, measuring about 8 miles. It may not be that wide, but the strait plays a crucial role in maintaining the liquid balance between these 2 bodies of water. About 6 million years ago, a bunch of things might have caused the Mediterranean to be cut off from the Atlantic Ocean. Some say it was an ice age. Others speak of tectonic movements, like earthquakes. Whatever the cause, it pushed the Mediterranean area into a period called the Mycenaean Salinity Crisis. For about 1,000 years, the sea slowly evaporated, leaving behind a dry basin that was several miles below sea level. This crisis really changed the landscape, creating conditions similar to those found in today's Dead Sea. What this means is that the lush Mediterranean beauty used to be a super salty environment, containing nearly 10 times more salt than the ocean. Say you could have visited. You would have been able to effortlessly float on the little water you could find, even if you're not a skilled swimmer. The amount of salt and that mineral content would have made it challenging for most creatures to survive. However, some hardy microorganisms, such as bacteria, could have adapted to these harsh conditions. These days, at the bottom of the Mediterranean Sea, we can find holes as large as the Grand Canyon, and they seem to have formed during that same period of dehydration. Evidence suggests that massive rivers, such as the Nile and the Rhone, flowed directly into the Mediterranean back then, leaving behind canyons as they reached the bottom, thousands of feet below the sea level. People had to find some sort of explanation back in the day for the drying of the Mediterranean, so they came up with myths and legends. One such tale was told by the people of southern Iberia, in modern-day Spain and Portugal. It was also recounted by a famous Roman writer called Pliny the Elder. What this legend said was that the Mediterranean used to be cut out from the ocean until the hero Hercules, with his mighty sword, carved a path. He did so between a fictional location in modern-day Africa and the Rock of Gibraltar. This allowed the ocean waters to flow in, transforming the Mediterranean into what we know today. Some fossils also seem to confirm the unusually large flood. Remains of marine organisms were found in layers high above current sea levels. This means the areas were once submerged underwater. These fossils belong to mollusks, fish, and marine mammals. Because of modern techniques, we now have at least an estimated timing of the Zanclean flood. Scientists used computer simulations to reconstruct the event, providing further evidence that it was real. What they also discovered is that there's a possibility the Mediterranean might change once more. The Strait of Gibraltar could close, most likely because of movements deep under the ground. This could lead to the Mediterranean becoming dry again, over a span of about 1,000 years. The Mediterranean area could disappear altogether if the African continent keeps shifting north too, getting closer to Europe. Another one of those famous yet still a bit hypothetical large floods is called the Black Sea Deluge theory. Some scientists think that around 8,400 years ago, water from the Mediterranean might have spilled over into the Black Sea through a narrow passage called the Bosporus Strait. This could have caused a massive disaster, forcing people living near the Black Sea to pack up their things and move further inside the continent, in both Europe and Asia. Along with them, they might have carried stories about this colossal flood. The specialist that came up with this idea also suggested that these migrating people might have brought along new ways of farming. Not everyone from the scientific community is convinced, though. Some argue that while there might have been a flood, it likely happened earlier and was way smaller. They didn't think this flood could have caused, for example, the story of Noah's Ark. In this legend, a spiritual man was warned by a higher entity that a giant flood was on its way. The man went to gather pairs of animals and pack them all in a boat to make sure these species would survive the devastating flood. There was also the concern among scholars that discussing real floods and ancient stories too much might blur the lines between science and fiction. There may be other reasons why these flood stories are so often found across different cultures all over our planet. One idea is that floods were incredibly destructive for early farmers, so they invented myths about them signaling the end of the world. Another idea is that people stumbled upon ancient sea creature fossils in unusual places, leading them to believe there was a significant flood in the past. The solution to future floods, though, might be floating cities. As sea levels continue to rise, coastal cities like Amsterdam, New Orleans, and Venice may go under. So, floating infrastructure may be the way to go, with buildings that can rise with the water levels, making them able to resist extreme weather too. Countries like the Netherlands, which have a history of managing water risks, are pioneering these floating creations. With cities running out of space for expansion, we might be forced to move on water anyway. By moving on the water, we can reduce crowding and create more interesting ways to feed ourselves, like floating gardens. These homes also come with great alternatives to our energy needs through systems that use solar and wind power. Not to mention that these homes might turn out to be cheaper in the long run. One such floating city might pop up soon in the Maldives. Its goal is to host up to 20,000 people and will feature places to live and eat, but also shops and schools. Designed to look like coral, the region will include canals placed between some 5,000 floating pieces of land. The city will be constructed using modular units, put together in a construction site nearby. After they're completed, they'll be towed to the floating city. The next step is to secure them to a large underwater concrete hull, which is screwed tightly to the seabed on some steel stilts. All these pieces of construction let the modular units easily move as naturally as the sea. Even for those that are afraid of seasickness, there's a solution. That's what the nearby coral reef is for. It will surround the city, making a natural wave breaker. Human-made coral banks will also be placed underneath the city, which will also help coral grow naturally. The long-term goal is to make the establishment self-sufficient. It will have electricity, mostly from on-site solar power. Waste will be treated nearby and reused as plant fertilizer. Instead of air conditioning, the city will use deep-sea water cooling. This method pumps cold water from the deep sea to cool the area, saving energy. Earth is not the only planet that's seen some serious floods. In ancient times, Mars seems to have experienced them too, and they played an important role in shaping its surface. Recent research reveals that billions of years ago, Mars was heavily affected by some serious river flooding, which contributed to the formation of its valleys and canyons. The reason for these floods was heavy rainfall, which reshaped the Martian landscape in a jiffy, at times even within days or weeks. Unlike Earth, where rivers form pretty slowly, Mars experienced rapid changes because of these floods, particularly around 4 billion years ago. We've known for quite some time that there have been floods on Mars, but this study really showed us their extent. We now know they were more widespread and frequent than previously thought.
Now, at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has 2 parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot, even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. And the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore, but when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lunch, lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they call that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novopangea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novopangea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat. A 4-story wall of water that only rises once in 1,300 years was recorded off the west coast of Canada. Some people blame waves like this for disappearances in the Bermuda Triangle. Rogue waves can get strong enough to sink container ships and oil rigs. The Canadian water monster didn't hurt anyone, but it did become a sensation. And it looks like we're about to see even higher and more powerful rogue waves in the future. The team of Marine Labs, the company that operates the buoy that got caught in the Ucluelet wave, couldn't believe the data they saw. A huge force came out of the blue, pulled the buoy down, and then set it up to a peak before taking it even deeper. They thought it must be a rogue wave, so they sent the data to a scientist at the University of Victoria who specializes in these beauties. They analyzed the data and confirmed it was indeed not a technical mistake. The wave officially became the most extreme rogue wave ever officially recorded, as it was 3 times the height of waves around it. Scientists have reported seeing giant waves coming out of the blue for centuries, but no one really believed them. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got in a terrible storm and saw several waves over 98 feet tall. It's almost as tall as a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and shared what they saw. But back then, scientists were sure waves couldn't be taller than 30 feet. Everyone took their story as a tall tale. Pun intentional. Over a century later, a cargo ship, the MS Munchen, mysteriously disappeared. People believed it to be unsinkable, just like the Titanic, so it was a real shock that all that was left of it was one lifeboat. When experts analyzed the damage, they concluded that it must have been hit by a wave that was around 65 feet high. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This monster on the North Sea that was 84 feet tall hit the Norwegian gas platform Doppler on New Year's Day. It was twice larger than the wave surrounding it. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. The wave wasn't like any other type of wave they'd studied before. So they had to admit rogue waves were real and gave them an official definition. It's a wave more than twice as tall as others around it. It can pop up lightning fast in a stormy sea, or show up out of nowhere in calm waters. These waves have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters trying to do their job. In 2007, America's National Oceanic and Atmospheric Administration made a list of 50 historical maritime tragedies that were most likely caused by rogue waves. Some of the events on the list happened not in the open water, but in lakes. Lake Superior has something that's got the name Three Sisters. It is a series of 3 large waves, one after another. The second wave covers the ship's decks before the first one is gone. The third wave jumps in and adds extra water. These 3 sisters overload the ship. There's a theory that this phenomenon took down the freighter Edmund Fitzgerald in 1975. There are two main theories trying to explain how rogue waves happen. First, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. When these waves cross paths, they team up and become stronger to turn into a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they exchange some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and put in a math model that would create a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but there is a huge progress in this direction. Scientists from the University of Melbourne went on an expedition to Antarctica and found out that strong winds play a big role in the creation of rogue waves. It looks like they're caused by a mix of strong winds and the random way waves move and interact with each other. This idea was tested in labs before, but now they've proven it happens in real oceans too. To study these waves, the scientists use special 3D cameras. These cameras work like human eyes, taking lots of images in a row to create a detailed 3D picture of the ocean surface. It showed that rogue waves happen more often when waves are young, which means they're just starting to form and are more affected by the wind. When strong winds blow over young waves, they make the waves taller, longer, and faster, but not evenly. Some waves steal energy from nearby waves and grow much bigger, which is how rogue waves form. The scientists noticed these giant waves happened about once every 6 hours. They recorded no rogue waves in calmer seas, when the wind doesn't have as much influence. Scientists are concerned that rogue waves may happen more often in the future because there's more energy in the atmosphere and ocean. It looks like rogue waves can be much more powerful than scientists ever thought. They managed to create the famous Doppler wave in a lab for the first time in 2018. This helped them study these mysterious waves up close and showed that their secret is in how they form. We think of waves rolling gently on a beach, but the waves in this study happen in open water when waves from different directions meet. When waves come together from far apart directions, they push the water upward, creating what's called a partially standing wave or a cross wave. This can happen when two seas meet, or when wind directions suddenly change, like during a hurricane. The study found that the bigger the angle between the meeting waves, the taller the cross wave becomes. Normally, when a wave breaks, it forms a white foamy top, and that's where it stops growing. But if a wave is formed by water coming from many directions, it can keep growing even after breaking. These special waves can grow to be twice as steep while breaking, which is already much bigger than normal waves. And if you add up all the growth from waves coming together, they can become 4 times steeper than what anyone thought was possible. This discovery could change the way we build things, like wind turbines or oil platforms in the ocean, to make them safe. Right now, many designs don't fully account for these huge multi-directional waves. Now, they seem to have a lot of similarities, but rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. So look at this narrow passage between the north of Morocco and the southern part of the Spanish region. It's called the Strait of Gibraltar. There are only 8 miles between the two continents, but for some reason, there's no bridge, despite people having been dreaming for centuries about connecting these two regions. There are places in the world where a bridge over water stretches for a much greater distance. For example, the Lake Pontchartrain Causeway near New Orleans, Louisiana, goes for 24 miles, which is 3 times the length of the hypothetical bridge between Africa and Europe. That's listed in the Guinness Book of World Records as the longest continuous bridge passing over water. It consists of 2 parallel bridges and connects the urban area of New Orleans with small settlements in the north of Lake Pontchartrain. 9,000 concrete piles hold more than 1,000 decks above the water. This large-scale structure was built in the middle of the 20th century. It only took 14 months from the start of construction to its completion. American engineers created a unique technology for attaching concrete piles to the base of the bridge, and this bridge is still functioning. So, what's the problem with building a shorter bridge to connect Africa and Europe? Let's first find out the value of the 8-mile bridge that could connect 2 continents and the reason why everyone is talking about it. In fact, the value of such a bridge would be enormous. Diamonds, oil, minerals. Africa is full of valuable materials, and Europe is happy to buy these things. This theoretical bridge could allow people to transport things for trade quickly and comfortably. But now, the exchange of goods between Africa and Europe is only possible thanks to airplanes and cargo ships, and airplanes are extremely expensive because of hefty fuel price tags. In addition, air travel is often delayed because of bad weather. There are long customs procedures and transportation from the airport to the destination. Ships can also be a problem. The narrow area of the Mediterranean Sea, where the 2 continents are closest to each other, is a dangerous place because of storms and strong currents. The transportation of your diamonds is highly dependent on weather conditions. The second advantage of such a bridge would be the creation of tens of thousands of jobs. People from Europe and Africa would build hotels, ports, parks, and even small towns for each other. The coastal parts of both continents would become a new economic center. And just imagine how much investment those places would attract. Europe and Africa would be much closer than ever before. You could drive from a small Spanish town to a safari park in northern Morocco, buy Moroccan tea, get some argan oil, and go home for the evening. Or you could take a high-speed train across the beautiful Mediterranean Sea. People would open hundreds of restaurants, amusement parks, shopping malls, and a museum next to this bridge. But, unfortunately, it's impossible to build such a bridge, at least at the moment. And here's why. The main problem is the Strait of Gibraltar itself, because of its strong currents and seismic activity. How can you start large-scale construction if, in a couple of days, an underwater earthquake can trigger giant waves and take all the ships underwater? Even if you build a bridge, rapid streams of water that constantly change direction can shake the entire structure and tear the connecting parts of the construction. The bridge over the Strait of Gibraltar must have a strong, sturdy system that will withstand seismic activity. Huge resources are required to create such a complex structure. Despite the dangerous passage between the 2 continents, it remains one of the busiest points in the world. It's the only place on the planet connecting the Mediterranean Sea and the Atlantic Ocean. About 300 ships pass through this area every day. Not only merchant ships, but also fishing vessels and tourist boats. There are not so many places in the world where you can watch whales coming out of the water. Not only people, but also marine creatures often visit this passage because of the peculiarities of the sea currents. But we'll talk about that later. Another problem is the depth of the strait. In simple words, any bridge over the water is built on long metal piles. Builders and engineers stick piles into the seabed and use them as a holding base for the whole construction. But installing such piles firmly enough is a difficult task because of the uneven seabed. The seabed has a unique geological landscape, irregularities, and different densities of the Earth's rock. There are also reefs, rocks, and pits. Any seabed requires extensive geological studies before piles are installed. However, the bottom of the Strait of Gibraltar is especially difficult because of its depth, almost 3,000 feet. It's one of the deepest straits in the whole world. Just imagine, you'll need the height of 10 Statues of Liberty to reach the surface of the water from the bottom of the strait. What kind of pile should be used there to hold the entire bridge? Most likely, one pile will have to consist of several parts connected into one large metal rod. And don't forget about seismic activity. Let's say you've installed perfectly strong piles, but the next day an earthquake occurs and destroys the entire structure. And a strong current is carrying fortifications all over the Mediterranean Sea. The next problem is probably the most important one, because it concerns marine life. The Strait of Gibraltar has a high salt content. This natural element makes water heavier and makes it descend to the bottom of the deep Mediterranean basin. Then, this salt water pushes up cold water from the seabed into the Atlantic Ocean. These changes in water density, as well as fast currents, create sea vortices and turbulence. It's like a raging cauldron of cold water that raises a lot of nutrients to the surface. The hollows and hills of the Strait of Gibraltar are filled with different substances and sunlight, and this creates ideal conditions for the formation of phytoplankton. Whales, dolphins, and other marine creatures adore this delicacy. That's why you can see about 7 species of whales and dolphins in this place. What might happen to phytoplankton after the start of global construction? Carbon dioxide, crushed rock, tons of dust and ashes, falling building materials, all of this could significantly pollute the environment. Without phytoplankton, many fish would go extinct. Without fish, thousands of fishers wouldn't be able to get food and earn money. But even if the bridge was built, cars and trains would continue to pollute the air and water. This disruption of the delicate balance in this narrow strait can lead to larger-scale environmental disasters. Dolphins and whales may leave to look for food elsewhere, and thus take resources from other marine inhabitants. Like falling dominoes, one problem can follow another. And all this because of one bridge. In 2007, the Spanish Ministry of Environmental Protection introduced speed limits for all ships sailing through the strait in order to not disrupt the delicate balance of nature. At the beginning of the 20th century, a French engineer proposed a project of a bridge, but it was rejected because it was too complicated and costly. People also tried to develop a 23-mile-long tunnel, but this project also faced financial and technical difficulties. People are still dreaming of a bridge over the Strait of Gibraltar. Perhaps, in the future, when we develop cooler technologies, we'll be able to build this thing. Oh, by the way, there hasn't always been water between these two regions. In the distant past, the two continents were connected. The entire Mediterranean Sea is the remains of the Tethys Sea that existed before the era of dinosaurs. Then the African and Indian plates collided with the Eurasian one, and the Tethys Sea completely disappeared. In its place, a land bridge was formed that separated the Mediterranean Sea from the ocean. Without access to water, the sea dried up about 6 million years ago. But then, when the bridge came down, the water began to fill the dried-up pool. For tens of thousands of years, the narrow plate sank lower and lower,